In this lesson, we want to talk about fundamental identities in trigonometry. So at this point, we've already talked about the reciprocal identities, we've talked about the quotient identities and the Pythagorean identities. If you forgot all that stuff because it's been a while since we covered it, it's okay. I'm going to pull up a quick little cheat sheet in a moment. Before we get into what we can do with the fundamental identities, I've got to give you one other piece of this puzzle, okay? And that's going to be the negative angle identities, which some books call the even odd identities, okay? So it just depends on your textbook which name you're going to use. Now, when we look at this little graph here, we're going to consider two angles. One is going to be this angle theta, okay? So here's your initial side, here's your terminal side. And you can see this point here on the terminal side is just marked with x comma y, just generically. If I had a negative theta, so the negative of this guy, so now we're moving clockwise, well, this point here on the terminal side, notice how it's x comma negative y, right? So this is the y up here, and this y down here is the negative of that. Notice how the x value is the same, okay? So we're going to use that to build this little relationship here. We're going to first start with sine of theta, okay? So sine of this guy right here, this would be equal to what? It's always y over r. But when I think about sine of negative theta now, how do things change? Remember, now I'm dealing with the negative of y, okay? So the negative of y over, it's still going to be r, okay? So what I can see here is that these guys are going to be negatives of each other. This guy is y over r, and this guy is going to be the negative of y over r. So I can use that to build a little relationship that's always going to be true, and I can just say that the sine of a negative theta is always going to be equal to the negative of the sine of theta, okay? So this is your first negative angle identity. Now, you might notice that this looks very familiar from earlier when we worked with functions and we talked about even and odd functions, right? This property here is from odd functions, right? So this is an odd function. If you had something like f of negative x, and you said this was equal to the negative of f of x, remember, this is an odd function. That's how you check for it. So let's erase this and think about cosine now. So with the cosine of, let's say, theta, okay, what is it? It's x over r. So it's x over r. But now when I look at the cosine of negative theta, okay, it's the same x, right? The x is the same. You have x comma y, you have x comma negative y. So x is not changing, okay? So we can say that the cosine of theta is equal to the cosine of negative theta. Remember, this is a property of even functions. So we'll say that the cosine of theta is equal to cosine of negative theta, okay? All right, so lastly, I'm going to take the relationships here, and I'm going to build something with tangent, okay? So I know that the tangent of theta is equal to the sine of theta over the cosine of theta. Now, let's think about this. If I had a negative theta, then all of these would just be negative theta, right? So if I erase this and put a negative theta, and I erase this, and I just put a negative theta in here, and a negative theta in here, what I want to do is think about how can I take what I just found here, plug it in there, and simplify and come up with something. Well, basically, we know that the cosine of negative theta right here tells me that's the same as the cosine of theta. So I can erase this and go back to the cosine of theta, and I can take this guy right here, the sine of negative theta, and I can basically pull the negative out in front. So let's get rid of that, okay? And I'll pull that out in front. So what does this tell me if I compare this one to the one I just had? So the tangent of theta, where it's the sine of theta over the cosine of theta, well, they're negatives of each other, right? So just like this first relationship. So we can say that the tangent of negative theta is equal to the negative of the tangent of theta. All right, so let me erase this. Using a similar thought process, we can get the ones for the reciprocals, okay? So basically the reciprocal of sine is cosecant, okay? So when you look at this, the signs are going to be the same, right? So basically it's the same property. So with this guy, let me put this down here in a different color. If I deal with cosecant, so cosecant of negative theta, it's equal to the negative of cosecant of theta, okay? With cosine, you have the reciprocal that's going to be secant, right? So I can do here, I'll drag this down here. Let me change my color. The secant of, let's say, negative theta will be equal to the secant of theta. Okay, so those match. Then lastly, this guy right here, let me change the color one more time. I think I'm running out of ink, so let me use this one. So here with the tangent, again, it's going to be, if you flip it, you get cotangent. So I'm going to say that the cotangent of negative theta is equal to the negative of the cotangent of theta. Okay, so these are the negative angle identities, or some books again call it the even odd identities, because of when we're talking about even and odd functions. Now I want to pull up this little PDF, which is attached at the beginning of this section for you. Okay, so I say keep this PDF handy. It's going to be very useful as a reference in this section. You want to start by just going back and forth and reading things and writing it out. Okay, as you get really good at working with these identities, you're going to commit these to memory. Okay, you're really going to need to do this before you get to calculus. So you have here the reciprocal identities. Okay, we have here the quotient identities. We have here the Pythagorean identities, and then the negative angle identities, which we just talked about. So we're going to use this in this section. Together, these are all called the fundamental identities. And we're going to start by just solving a problem that we've already seen how to solve before. Okay, we're just going to do it in a different way. So we have the tangent of theta equals 3/4, and sine of theta is positive. Okay, so let's stop for a minute. This tells us we're where. Remember, the all students take calculus. So if I draw a little coordinate plane here, the all students take calculus. Okay, everything is positive in the first quadrant. In the second quadrant, it's sine and cosecant. In the third quadrant, it's tangent and cotangent. And in the fourth quadrant, it's cosine and secant, okay, in terms of what's positive. So here we have that tangent is positive and so is sine. So that means I have to be in quadrant 1. Okay, so before you do anything, let's just figure that out. And we're just going to put here that we're in quadrant 1. Okay, so I want to find the secant of theta, the sine of theta, and the cotangent of negative theta. So let's start out with the secant of theta. How can we figure this out using identities? Well, let me pop this back open, and I want to look for a relationship between tangent and secant, okay? And I see that I have one here, tangent squared theta plus 1 equals secant squared theta. So let's go ahead and write this out. So we have that the tangent squared theta, then we have plus 1 is going to be equal to the secant squared theta. Okay, so remember, and this is going to come up later on when we're simplifying trigonometric expressions, this is the same as if I had tangent theta squared. Okay, this is just a different way to write this. So what I'm going to do is I'm going to plug in for what I have. So I'm going to plug in the 3/4 there. This is 3/4 and it's being squared. Okay, that's why I just showed you that. So let's erase this and put 3/4 here. And I'm going to square this guy, okay? And so if I square 3/4, I get 9/16. And let me scroll down to get some room going. We'll come back up and answer this. So this will be 9/16 plus 1. Now, to do anything here, I know I need to get a common denominator, so I might as well just write this as 16/16 and just go ahead and add. 9 plus 16 is 25. So this would be 25/16, okay? So this equals secant squared theta. Now, I want to get this guy, this secant of theta by itself, because that's what I'm told to find, right? I want to find secant of theta, not secant squared of theta. So to do this, I want to take the square root, okay? But I need to know which one to take, and I need to think about, okay, well, if I'm in quadrant 1, everything's going to be positive, okay? So I just want the principal square root. So I'm going to take the principal square root over here, and this guy over here will now be just secant of theta, okay? So here I can simplify and say, and I'm just going to flip this around and say the secant of theta is equal to the square root of 25 is 5 and the square root of 16 is 4. So this guy is going to be 5/4. Okay, so that's one way we can do it. Obviously, we saw earlier in the course that we could have done this a different way. Whichever way you want to do it, I'm just showing you different ways you can attack the same problem. So let's put this up here. Let's erase all this and let's just drag this up here and we'll attack the next part of that problem. So we have here, if we come up here, we want to find the sine of theta. Okay, so let's think about this. And there's a lot of different ways to do this. But again, if I go back to my little cheat sheet, I want you to see this quotient identity here where the tangent of theta, again, is the sine of theta over the cosine of theta. Now you might think, well, we don't have cosine of theta, but we do because of the reciprocal identities. We just found the secant of theta, which is 1 over the cosine of theta. Okay, so let's go ahead and put this down here. I'm going to first just write the relationship that the tangent of theta is equal to the sine of theta over the cosine of theta, okay? And the cosine of theta is 1 over, so it's 1 over the secant of theta, okay? So you know you can flip this, and you would basically have the secant of theta, okay, times the sine of theta, but I want to solve for this guy, so I'm going to divide both sides by the secant of theta, and that's going to give me the sine of theta by itself. Now, all I have to do is plug in the information I'm given. So I have for the tangent of theta 3/4. So I have 3/4. For the secant of theta, I just found that was 5/4. Okay. So basically what I'm going to do here is say, and let me scroll down and get some room going. I'll come back up. I have 3/4 times, I'm going to flip this because I'm dividing fractions. So 4/5. We can see that this is going to cancel and I'm left with 3/5. So that's going to be my sine of theta. So let's go ahead and put this over here and say that my sine of theta is equal to 3/5. Okay, for the last part of this problem, we're asked to find the cotangent of negative theta. So the cotangent of negative theta, okay, let's just pop open this guy again. We can see the cotangent of theta is 1 over the tangent of theta, okay? So I could say this is 1 over the tangent. In this case, I have a negative theta, so negative theta, okay? And then from here, I'm given that the tangent of theta is 3/4, but I want the negative of that. Remember, you can pull this out. We saw that earlier. So you might as well say that this guy is going to be equal to 1 over the negative of 3/4, okay? So to finish this up, I'm just going to flip this and say that the cotangent of negative theta is going to be equal to the negative of, again, flip this guy, it would be 4/3. So those are going to be your answers here, okay? You're going to have the secant of theta is 5/4, the sine of theta is 3/5, and the cotangent of negative theta is negative 4/3. All right, so the next thing we want to do is we want to write one trigonometric function in terms of another. So you're going to see this in your book. Let's say you see something like the cosine of theta, and you're asked to write this in terms of, okay, so in terms of the tangent of theta, okay? So how can we do this? Well, the first thing you want to do is you want to find an identity that's going to work, where it's going to relate your trigonometric function, which in this case is the cosine of theta, to the tangent of theta. So if we go back here, I'm going to pick this Pythagorean identity here. So I'm going to pick this guy, which involves the tangent of theta, okay, and the secant of theta. So what we're going to do, let's go ahead and minimize this. I'm going to go to the next page. I've already written it down. So we have 1 plus the tangent squared of theta is equal to secant squared of theta. Remember, when you think about the secant of theta, it's 1 over the cosine of theta, okay? So what I'm going to do first is just take the reciprocal of each side. So I'm going to say this is 1 over 1 plus tangent squared theta is equal to 1 over secant squared theta, okay? So now I'm going to replace. I know that this guy right here, again, because of the reciprocal identities, is going to be cosine squared theta, okay? So I'm going to replace this. On the left, I'm going to say 1 over 1 plus tangent squared theta is equal to, on the right, I'm just going to put cosine squared theta. Now, I want this in terms of cosine of theta, okay? So I'm going to take the square root of these sides here. On this side, I want plus or minus because I'm not given a quadrant, okay? So I don't know any information about what quadrant I'm in. So I'm going to write this. Let me change the color here. I'm going to put cosine of theta is equal to plus or minus the square root of this whole thing. So 1 over, you've got 1 plus your tangent squared theta, okay? So from here, we know that we can take this and make it a 1. So let's go ahead and say cosine of theta is equal to, I'm going to go plus or minus this 1 up here, over, down here I'll have the square root of 1 plus the tangent squared theta. Okay, so we want to always rationalize our denominator. So to do that, let me scroll down and get some more room going. I'm going to multiply this by the square root of this guy, so 1 plus your tangent squared theta over square root of 1 plus your tangent squared theta. Okay, so that's just going to rationalize the denominator. So I'm going to have cosine of theta is equal to, so this guy right here, I'm just going to have plus or minus. Remember, 1 times anything is just itself, so I'll have the square root of 1 plus tangent squared theta over, this times this would give me the radicand there, so 1 plus tangent squared theta. Okay, and we're done. So that's the exercise here. It's just meant to give you some practice writing one trigonometric function in terms of another. Okay, so now let's move into actually simplifying, okay? And I think you'll find that once you get started on simplifying and writing things in terms of other things, at first it's a bit challenging, but really once you practice enough, this becomes really, really easy. So we have the secant of theta times the cotangent of theta times the sine of theta. So when you get a problem like this, you want to think about putting your expression in terms of sine and cosine, okay? And if you have sine or cosine in your expression that you're trying to simplify, leave it alone. Don't try to mess with that, okay? You want to mess with everything else. So I'm going to leave this as it is, and I'm going to change this one and this one. So because there's multiplication here, when I go back, I'm going to be thinking about my reciprocal identities, okay? So I'm going to be using these guys here to simplify. So basically, the secant of theta is 1 over the cosine of theta, okay? The cotangent of theta, I know, is found by flipping the tangent of theta. So it's going to be the cosine of theta over the sine of theta, okay, over the sine of theta. And then this is times this sine of theta. So you see that when you plug these things in, a lot of stuff's going to cancel. So this cancels with this cancels with this, and I'm basically just left with 1. Okay, so this is pretty common. When you just see multiplication like this, if you have sine or cosine, leave it alone. Okay, the other stuff is what you want to plug in for and try to see what you can get to cancel. Now, let's take a look at another example where we're simplifying a trigonometric expression. This one is going to be problematic for a lot of beginners because of the notation here. So I want to make sure you understand the notation. So when we work with, again, something like sine squared theta, remember this is the same thing as if I said sine of theta being squared like this. It's very important you understand that. When you look at this guy right here, the temptation, because of sine of negative theta, okay, is equal to the negative of the sine of theta, the temptation here is to do what? It's to go the negative sine squared theta, okay? That's not actually accurate, okay? You have to think about it like this guy right here, okay? So the way I want to write this is I want to make it crystal clear what's going on, and I want to say that I have the sine of negative theta, okay, this guy being squared, okay, the whole thing being squared. Then plus, I'm going to do the same thing here. So I'm going to have the tangent of this negative theta, okay, this guy right here being squared. Then plus, I'm going to have the cosine of this negative theta being squared, okay, the whole thing being squared. So now it's crystal clear, okay, when I pull this negative out, what's going to happen? We're going to have the negative of sine of theta, but the thing is squared, plus, pull this out, okay, I'm going to have the negative of the tangent of theta, and I don't need parentheses in that case, okay, and then this guy's going to be squared, and then plus, in this case, you don't need to pull anything out because the cosine of negative theta is equal to cosine of theta, okay, so I can just say this is the cosine of theta being squared, okay? So now I want you to see what I'm getting at here. Basically, if you had incorrectly pulled that out and said you had the negative of sine squared theta, you would get the wrong answer, okay? Because this guy right here, because you're squaring the negative, it becomes positive, right? So this is going to go away. So you get rid of that, and you basically go back to having sine squared theta. Not the negative of sine squared theta, sine squared theta, okay? Because this negative got squared. Same thing here. This negative is going to get squared. So plus tangent squared theta. Then plus, you have your cosine squared theta. Okay, so from here, that's the first step, just to understand where you're going there. But from here, you want to realize that if you're dealing with something that's squares here and you've got pluses and minuses involved, not in every case, but usually you want to look at the Pythagorean identities. So if we pop these open, you see that sine squared theta plus cosine squared theta is 1. So that's the first thing I'm going to do. You can consider this plus this to be 1. You can reorder this if you want to make it crystal clear. So we'll say sine squared theta plus your cosine squared theta plus your tangent squared theta, okay? This guy right here is equal to 1, okay? We just saw that. So I'm just going to substitute. So I'm going to put in here a 1 plus the tangent squared theta. Now, can we make this simpler? Let's go back and see if there's anything that involves tangent squared theta and 1. Yes, right here. Tangent squared theta plus 1 is equal to secant squared theta. So I can replace this with just secant squared theta. Okay, and that's going to be my answer. And you can see how we really simplify this down to just one of these guys. In this lesson, we want to talk about verifying trigonometric identities. All right, so in this particular section, you might struggle a little bit when you first get to it. It's a topic that you really need a lot of practice with. it's not as straightforward as other topics where you have a set list of things that you need to do. Okay. If you were solving basic equations, I could give you the steps and you could perform those steps and basically you would get the right answer all the time. With this, there are just hints or strategies you can use to arrive at the correct answer, but it's not so clear in terms of what you need to do. And there's also multiple ways to do the same thing. Okay, so I have some little tips here for you, and they're standard from any textbook. Okay, so you'll get this in any textbook. The first thing is to memorize the fundamental identities. So again, in the last lesson, we talked about these fundamental identities, and we talked about simplifying trigonometric expressions using the fundamental identities. Again, we looked at a little handout here, so hopefully you have that again, and you want to memorize these. So you have the reciprocal identities, you have the quotient identities, the Pythagorean identities, and then you have your negative angle, or again, some books call this even odd identities. So all of these are going to play a crucial role when you're verifying these trigonometric identities, okay? So here are some other tips. You always want to try to work on the more complicated side, okay? So when you're verifying trigonometric identities, you're not going to be doing the same thing as when you solved equations. When you work with equations, you might multiply both sides by the same number or add the same term to both sides, something like that. Here, you're not going to do that. You're going to work on one side, generally speaking, the more complicated side, and try to make it match the other side, the simpler side. Okay. Another tip is sometimes you'll want to express everything in terms of sine and cosine. That doesn't always work, but it's just a general tip. Okay. You want to perform any indicated algebraic operations such as factoring or expanding. Here you want to think about all those special product formulas, okay, and all the special factoring formulas. Those are going to come up a lot. And then we have use the formula for multiplying conjugates. So remember, if you have 1 plus sine of x times 1 minus sine of x, this is going to be 1 squared, which is 1, and then minus sine squared x. So basically 1 minus sine squared x, and we know from our Pythagorean identities, this is going to be exactly equal to cosine squared x. Similarly here, I could make this 1 minus cosine squared x, okay? And that's going to be exactly equal to sine squared x. Okay, so let's take a look at the first example. And the first few of these are going to be really, really easy. So go ahead and pause the video and try them on your own once I kind of get going here, and then see the solution. So the first thing is I'm going to think about which side is simpler. So to me, this side is simpler, okay? So I'm going to try to work on this side on the left. Now, pretty much every book that you're going to see has different formatting. Generally speaking, they sometimes will take this guy right here and just work on the more complicated side, and at the end, they'll show you that it matches. What I'm going to do here is I'm just going to take this guy and flip it. So I'm just going to say I have 1 plus sine of x is equal to, over here I'm going to have cosine of x plus cotangent of x, okay, over the cotangent of x. I'm flipping it because what I'm going to do is modify the right and leave the left alone. Okay, so that's generally the formatting you're going to see. If your teacher tells you to do something else, then follow that. Okay, so what I'm going to do is just put equals over here. I'm not going to mess with this. My goal is to get this side right here to match this 1 plus sine of x. So the first thing I'm going to do is I'm going to write things in terms of sine and cosine. So I have cosine here, okay, so I'm not going to touch that. But cotangent of x, again, if you think about the reciprocal identities, it's cosine of x over sine of x. So I'm going to start by saying I have cosine of x plus cosine of x over sine of x. And this is over, again, if I have cotangent of x, I'm going to write it as cosine of x over sine of x. Okay, let's scroll down and get some room. We'll come back up when we get to a stopping point, okay? So what I want to do here is think about the fact that I have basically a complex fraction, right? So how do you simplify that? You look at the denominator, so I have sine of x and sine of x. So if I multiply this by sine of x over sine of x, basically I'm going to distribute this here and here, okay, and I'm going to distribute this here. So I'm just going to keep my equals over here, okay? We might need more room, so let me just kind of slide this down a little bit. Sine of x times cosine of x is just sine of x times cosine of x. Then plus sine of x here would cancel with sine of x here, so I just have cosine of x here, okay? Then down here, this sine of x here would cancel with this sine of x here, so I'm going to put this over just the cosine of x. Okay, so let's go down a little bit more, and let's think about something here. We have the cosine of x and the cosine of x. What operation could I do there? Well, I could factor, right? So I'm going to put equals here, and I'm going to pull that guy out, okay? So I'm going to say I have the cosine of x. Inside the parentheses, I'll have the sine of x, okay? Plus, if I pull this out, I have a 1, okay? Then this is over the cosine of x. And now what I'm going to do is I'm going to cancel this with this. And what I'm left with is going to be the sine of x plus 1, okay? If we go all the way back up, we see here that we have 1 plus sine of x. And here we have sine of x plus 1, right? So I could write this as 1 plus sine of x, okay? And then I'm just going to put a big check mark here to show that this right side now here matches the left side, okay? So you could have gone about this a different way. There's multiple ways to verify a trigonometric identity. The main thing is, again, start with the more complicated side, work your way down, okay, and try to make it match the other side. Okay, so once you've found that it matches, you're done. Put your check mark and move on. Try to make your steps as clear as possible so that whoever is grading it can give you full credit. Okay, let's take a look at another example. This is another kind of easy one. So we have the cotangent of theta over sine squared theta equals cosecant squared theta over tangent of theta. Now, in this particular case, both sides are equally complex. So I'm just going to leave the left one alone because it already contains sine, okay? If you wanted to do it a different way, again, that's fine. So I'm just going to basically put equals here, and I'm going to manipulate this in terms of sine and cosine. So cosecant, okay, if I think about the reciprocal identities, is 1 over sine, okay? So basically, I can say cosecant squared of theta is 1 over sine squared of theta, okay? And then over tangent of theta is going to be my sine of theta over my cosine of theta, okay? So what I want to do here, think about the fact that you are basically going to flip this guy, okay? Basically, if you're going to divide fractions, you multiply the first fraction by the reciprocal of the second guy, okay? So let's scroll down a little bit. And I'm going to go 1 over sine squared theta times, this is going to flip, so it's going to be cosine of theta over sine of theta, okay? And can anything cancel here? Well, no, you might be expecting to cancel sine of theta. So at this point, you might stop and say, well, what's going on? So let's go back up here, okay? Let's think about what we have. We have cotangent of theta over sine squared theta. Well, I have sine squared theta here. This right here, if you really think about your reciprocal identities, remember cosine of theta over sine of theta is cotangent of theta. So I can replace that, okay, I can replace that with cotangent of theta, okay, so I can put 1 over sine squared theta like this, multiply it by cotangent of theta, okay, and basically we're done, right? All we have to do is multiply this through and say I have the cotangent of theta over sine squared theta, okay, so now your left side and your right side are going to match, so you put your check mark there. Again, just make sure you show your steps so your teacher can give you full credit. All right, for the next one, we have the negative of cosecant squared theta times cosine squared theta is equal to 1 minus cosecant squared theta. So for this guy, you might be thinking that the right side is a bit more complicated. It looks kind of like the difference of squares, right? So it is, actually. You could factor that if you wanted to. But I'm not going to do that. I'm going to leave this side alone. Whenever I see something that looks like this, I'm thinking about the Pythagorean identities. I have a minus or a plus with a 1 here, and this is squared. If I look at my little handout here, I want you to think about this one right here. So 1 plus cotangent squared theta is equal to cosecant squared theta, okay? So we'll come back to that in a moment. And I'm just going to work through this. I'm going to flip the sides here. I'm going to put 1 minus cosecant squared theta, okay, is equal to, I'm going to put negative cosecant squared theta times the cosine squared theta, okay? So what I'm going to do first is just take this side right here and express it in terms of sine and cosine. Again, for a lot of these problems, that ends up being all you really need to do to end up with a solution. So I'm going to put equals over here. I'm going to change this. I'm going to put my negative out in front. Cosecant squared theta, again, with the reciprocal identities, I can put 1 over sine squared theta, okay? This is times cosine squared theta. And then over here, I have the negative of, I'll say, cosine squared theta over sine squared theta. Can I make a replacement here? Yes, because this guy right here is the cotangent of theta, right? So basically what I have, let me scroll down a little bit, is the negative of the cotangent squared theta. Now, can I do anything with this? Remember, I talked about this Pythagorean identity here, okay? Let's assume I moved this over here and this over here. So basically I would have 1 minus the cosecant squared of theta is equal to the negative of cotangent squared theta. So right now I have the negative of cotangent squared theta, and I can replace it with exactly this right here, 1 minus cosecant squared theta. Okay, so that's what I'm going to do. So I'm going to say this guy right here is 1 minus the cosecant squared theta. Okay, so now my left side exactly matches my right side. I'm going to put my check mark there, and I'm done. All right, let's take a look at a harder example. So here we have 2 times the tangent of theta times the secant of theta is equal to 1 over 1 minus the sine of theta minus 1 over 1 plus the sine of theta. So when you see this guy right here or this guy right here, you got to be thinking about conjugates, okay? So I'm definitely going to leave the left side alone, and I'm just going to play with this right side. Before I do anything, I just want to do this off to the side so I have a lot of room to work. I know that I would want to get a common denominator here. Okay, so how would I do that? Again, I'm thinking about conjugates. So here I would multiply by 1 plus the sine of theta. Okay, here 1 plus the sine of theta to make that legal. Again, this is 1. I can multiply these together. So you see how this formula is going to work. If you had a minus b, that quantity, times a plus b, this quantity. Remember, this is a squared, first guy squared, minus b squared, minus the second guy squared. Okay, in this case, it's going to be no different. This is going to end up being 1, the first guy squared, then minus, you have sine squared theta, so sine squared theta, this second guy squared, okay? So up here, this would just be 1 plus sine of theta, okay? You can get rid of this, and then down here, this is going to be 1, you don't need 1 squared, minus the sine squared theta. Okay, so that's going to be this part right here. For this part right here, I have a plus here, so basically, this part is going to be a minus. So I'm going to put a minus here, and I'm going to end up with what? 1 minus sine of theta in the numerator, because again, I'm going to multiply by 1 minus sine of theta here, and 1 minus sine of theta here, and then down here it's the same thing, right? It's the same thing, so it's going to be 1 minus sine squared theta, okay? So let me erase this, and let me slide this over so I can get my formatting right. Slide this over just a little bit, put equals there, and again, I can write this with a common denominator, so you can even do this real quick right here so we save a little bit of time and a little bit of effort. So let me just put 1 minus sine squared theta like this, and then I'll put this as 1 numerator with a minus here, but be very, very careful. When you're subtracting this away, you're subtracting away the whole thing. So go ahead and wrap that in parentheses to remind you that you need to change your signs because you're subtracting the whole thing away. Okay, so let's keep going and see what's going to happen here. So I'm going to have 1 plus sine of theta. Again, you're distributing this negative. So minus 1, distribute the negative here, so plus sine of theta, okay? And this is over 1 minus sine squared theta. So what can we do here? Well, we see immediately that this is going to cancel, okay? So now I basically have 2 times sine of theta. So 2 times sine of theta over 1 minus sine squared theta. Now, remember in the hints, we saw that 1 minus sine squared theta was cosine squared theta. Again, if you go back to this, if you have this guy right here and you just subtract this away, so 1 minus sine squared of theta would give you cosine squared theta. So if we come back here, I can replace this with cosine squared theta. So let's go ahead and do that. So I'm going to put equals 2 times sine of theta over the cosine squared theta, okay? Now, is this getting close to what we want? Let's go back up and see where we are. We have 2 times the tangent of theta times the secant of theta. So are we close to that? Well, I see I have the 2. I need the tangent of theta and the secant of theta. So to get this, I'm going to break this up. Remember, cosine squared theta can be written as cosine of theta times cosine of theta, okay? It's just this times this gives me cosine squared theta. Now, up here I have 2 times sine of theta. Now think about it. If I have sine of theta over cosine of theta, that's the tangent of theta, okay? And if I have 1 over cosine of theta, that's the secant of theta. So I already have what I need, okay? You just need to break things up so you realize what's going on. So I'm going to put this as 2 times sine of theta over cosine of theta times 1 over cosine of theta. And then I'm just going to, again, replace this with what I'm looking for. So in this particular case, it's going to be what? 2 times, this is going to be the tangent of theta times, in this case, this is going to be the secant of theta. And now the left side and the right side perfectly match. So I'm going to go ahead and put my check mark there. And again, I'm done. All right, let's take a look at one final problem. And this guy's going to be pretty challenging overall. So I encourage you to pause the video and try this on your own. But before you do so, I want to just give you a little hint that you basically want to get both of these to a common expression. Okay, so you want to work on one side, get it down to in terms of sine and cosine. This side is pretty hard if you are not used to working with these. This side's pretty easy. Okay, so you want to get it to this common third expression. So go ahead and pause the video and try it. And hopefully you did give that a try. And I'm just going to start with the left-hand side here, okay? So I'm going to start by just taking this guy and trying to write it in terms of sine and cosine. So how can I do that? Well, let's start out by just putting that we're working on the left-hand side. Okay, some teachers want you to do this. Others don't care, so just get with your teacher. And I'm going to first copy the left-hand side. So I have the secant of x plus the tangent of x over the secant of x minus the tangent of x. Now, lots of ways to do this. I'm going to go through one that is probably not obvious if you haven't worked a lot of these problems. Remember, the secant of x, by definition, is equal to 1 over the cosine of x, okay? So if I multiplied this secant of x, which is 1 over the cosine of x, times the cosine of x, I would get 1, okay? So in other words, if I did this guy right here, let me just copy this real quick. So secant of x plus the tangent of x over the secant of x minus the tangent of x. If I multiply this guy by the cosine of x over the cosine of x, when I distribute this here, this is going to be 1. When I distribute this here, this is going to be 1. Another benefit is when I distribute this here and this here, think about the fact that the tangent of x is the sine of x over the cosine of x. So the cosine of x is going to cancel in each case. So I'm going to end up with 1 plus the sine of x and 1 minus the sine of x. So that's pretty simple, okay? So that's how I'm choosing to do this. Again, you could arrive at this a different way. So let me just put equals over here. This multiplied by this is going to give me 1, okay? And then plus, let me just write this out. So the tangent of x times the cosine of x. We know we can cancel that further. And then we have, again, cosine of x times secant of x is 1 minus, we'll have the tangent of x times the cosine of x. Okay, so from here, I'm going to, again, keep simplifying. Let's put 1 plus, I'm going to do sine of x over cosine of x times the cosine of x. Again, this is going to cancel. So this cancels with this. And this is over. Let me get some more room here. I think I'm going to run out. So we have 1 minus, again, I'm going to write this as the sine of x over the cosine of x times the cosine of x, okay? So this is going to cancel, and I have the sine of x there, okay? So let's just write this one more time. We'll put 1 plus the sine of x over 1 minus the sine of x. So that's pretty simple. It's in terms of sine, okay? And basically, now what I want to do is try to get the right-hand side to match this, and you're going to find that that's pretty simple. So let me start a new sheet here. And I'm going to say the right-hand side. Okay, and let me make that a little bit better. So let me put the right, and I'm going to try carefully to write this. So right-hand side. Okay, penmanship is hard for me. So let's come back up, and let's think about this guy. So we have 1 plus 2 times the sine of x plus sine squared of x over cosine squared of x. So let's come down. So we have 1 plus 2 times the sine of x plus sine squared of x, okay, over, we're going to have the cosine squared of x. So the first thing is, you should be thinking about factoring when you see this pattern. Again, this is basically where you have x plus y quantity squared, right? It becomes x squared, so first guy squared, plus 2 times the first guy times the second guy, so 2 times xy, plus the last guy squared, okay? That is exactly the pattern you have here. This is going to be basically 1 plus sine, okay, of x, quantity squared. So I'm going to take this guy, and let me do this properly. So let me just kind of slide this down a little bit, okay? I'm going to put equals. So I'm just going to say this is 1 plus the sine of x, quantity squared, over your cosine squared of x, okay? So I'm going to put equals over here. So what am I going to do with this now that I've factored it? Well, again, if you see something like cosine squared of x, and you see something in terms of sine of x, I want you to think about the fact that this can be replaced with 1 minus sine squared of x, okay? So I'm going to write this as 1 plus sine of x, quantity squared, over, this is going to be 1 minus sine squared x. So at this point, some of you are thinking that there's something weird going on. This doesn't match this, but it will in a second. This is the difference of squares, so you need another factoring pattern here. This is 1 squared, basically, minus sine squared x. So I'm going to rewrite this, and then it's going to be completely obvious what's going on, okay? So first, let's go ahead and write this as 1 plus sine of x times 1 plus sine of x. Okay, so I'm just expanding this. Nothing illegal about that. I have an exponent of 2 there, so I'm allowed to do that. Okay, then down here, I'm going to factor this as 1 plus sine of x times 1 minus sine of x. And now it is completely clear what I'm doing. Okay, so this cancels with this, and I have 1 plus sine of x over 1 minus sine of x. Again, if we go back, what did we have here for our left-hand side when we worked it? 1 plus sine of x over 1 minus sine of x. So what I'm going to do here, I'll just put equals 1 plus sine of x over 1 minus sine of x. And to complete this guy, you might just want to write your basically 3 expressions here. So I'm going to say that the secant of x plus the tangent of x, so plus the tangent of x over, and I don't know if I can fit this all on the screen, but I'm going to try. So the secant of x minus the tangent of x, let me scroll this down and try to write smaller, is equal to, we have this 1 plus the sine of x over 1 minus the sine of x. So this is what we found from working the left side and the right side. Okay, so this is your basically your common third expression. Okay, and this is going to be your 1 plus your 2 times sine of x plus sine squared of x. Let me see if I can scooch this down just a little bit more. And then over, you had your cosine squared of x. Okay. So this is going to basically do it for this guy. Again, you're not going to probably see too many of these if you're on a basic test. You're probably going to get maybe one of them towards the end. They realize how much time these guys take, okay? So if you get something where you're just working and working and working on one side, you can't get it anywhere, go ahead and get it in terms of sine or cosine, stop, and then start working the other side. See if you can get it to match. In this lesson, we want to talk about the sum and difference identities for cosine. All right, so as we continue to work through our chapter on the trigonometric identities, we're going to come across the sum and difference identities for cosine. So this guy right here might not be completely intuitive. A lot of students, if they see something like the cosine of, let's say, this a plus b here, well, they might try to distribute the cosine and say this is the cosine of a plus the cosine of b. But that doesn't work. Okay, so you have to use this identity here and say that the cosine of a plus b would be the cosine of a times the cosine of b minus the sine of a times the sine of b. Okay. Now you'll notice here that this is plus and this is minus. So remember, the signs here are going to be different. Then for this guy, it's going to match except for the signs, right? Because now we have the cosine of a minus b. This will be the cosine of a times the cosine of b plus now the sine of a times the sine of b. So again, this is minus and this is plus. So let's start off with a simple example. And here we're given the cosine of 75 degrees. So this type of example, you're meant to give an exact value, okay? So the way you're going to do this is you're going to break 75 degrees up into 2 angles that's going to be on the unit circle, okay, where you're going to know what this cosine value is going to be. So I can break this up. One way to do it would be 45 degrees and 30 degrees. So I'll just say this is equal to the cosine of, and I'm just going to go 45 degrees plus 30 degrees, okay? And then I'm just going to use my little formula. So we'll have what? You want the cosine of this guy, so the cosine of 45 degrees, times the cosine of this guy, the 30 degrees. Remember, your sign is going to alternate. So because in this particular case, we have a plus, we want a minus there. Okay, so you want to change your sign. And then now I want to go with the sine of these 2 angles. So the sine of 45 degrees, and then times the sine of 30 degrees, okay? So you're multiplying here, you're subtracting between the 2, okay? So now what I want to do is just come through here and replace these with the actual values. So if you go to your unit circle and you go to 45 degrees or pi over 4 in terms of radians, you see that it's square root of 2 over 2 for the cosine, and then it's square root of 2 over 2 for the sine. Remember, this is the x, that's the cosine, this is the y, that's your sine. So square root of 2 over 2 in each case. So this is square root of 2 over 2, and this is square root of 2 over 2, okay? So what's going to be for 30 degrees? Let's go back. For 30 degrees or pi over 6 in terms of radians, you've got square root of 3 over 2 for your x or your cosine, and then 1/2 for your y or your sine. So this is going to be the square root of 3 over 2, and this is going to be 1/2, okay? So now all we have to do is just some basic arithmetic. So let's come down here a little bit, okay? And then let's switch the color here. So this would be the square root of 2 times the square root of 3. That would just be the square root of 6 over 2 times 2, which is 4. Then minus the square root of 2 times 1 is just the square root of 2, and then over 2 times 2, which is 4. Now, the only thing you can really do here is write this with a common denominator. So I'm just going to say that this is the square root of 6 minus the square root of 2. You can't combine there because the radicands are different, okay? You have the same index but different radicands, so you can't really combine those. So then this is over the common denominator of 4, and this would be your exact value for the cosine of 75 degrees. All right, let's take a look at another example. So we're just trying to find the exact value again. So we have the cosine of pi over 12. So obviously this is given in terms of radians now. So what I'm going to do, and this is just a personal preference, I'm going to first convert this to degrees. It's a little bit easier for me to find two angles to add or subtract depending on what you want to do. So I'm going to multiply pi over 12 in terms of radians times 180 degrees over pi. And then basically I'm going to cancel this with this. 180 degrees divided by 12 would be 15 degrees, okay? So basically if I had 15 degrees, what I'd want to do is add and subtract. Let's say I did 45 degrees minus 30 degrees. That would give me 15 degrees, okay? So I could say this is the cosine of, if this is in terms of radians, 45 degrees is going to be pi over 4, okay? So pi over 4. And then minus 30 degrees is going to be pi over 6, okay, in terms of radians. So I'm just going to use my formula from here and just say that I have the cosine of pi over 4 times the cosine of pi over 6. Because this is minus, I now want a plus. So I'm going to do the sine of pi over 4 and then times the sine of pi over 6, okay? So let me put my equal sign there so we can keep going. And then I'll put equals over here. So if I think about pi over 4, or again, 45 degrees, I know the cosine of 45 degrees and the sine of 45 degrees, that's going to be the square root of 2 over 2 in each case. If I go back to my unit circle, you can see for 45 degrees or pi over 4 in terms of radians, we got square root of 2 over 2 and square root of 2 over 2. So let's go back and just replace this with the square root of 2 over 2. And the square root of 2 over 2. Now for pi over 6 or 30 degrees, we have again square root of 3 over 2 for the cosine and 1/2 for the sine. So this is going to be the square root of 3 over 2, and then we're going to have 1/2, and then I'm going to put a plus here between them, okay? So let's go ahead and scroll down a little bit and do some arithmetic. So this would again be the square root of 6 over 4. Now plus, now I'm going to have the square root of 2 times 1, which is just the square root of 2, over 2 times 2, which is 4, okay? So again, pretty much all we're going to do here is just write this with a common denominator. I can't add the square root of 6 and the square root of 2. I can't combine those radicals there because this and this is different, right? So you have different radicands, same index but different radicands. So I'm just going to write this as the square root of 6 plus the square root of 2 over the common denominator of 4. So this will be my cosine of pi over 12 radians. Okay, let's take a look at one more of these. So you might see the problem that we just worked on, those two problems, rearranged. So now you see the cosine of 83 degrees times the cosine of 38 degrees plus, this is the key here, the sine of 83 degrees times the sine of 38 degrees. So you see that you have the cosine of some angle times the cosine of some other angle, okay? And then you have the sine of that first angle, so the angles here match, and then the sine of that other angle. Okay, so the angles there match, and you have a plus between them. You're meant to realize that you could write this as the cosine of, again, this is a plus, so I want a minus. So I'm going to do the 83 degrees minus the 38 degrees, okay? So what is this going to be? if I do 83 degrees minus 38 degrees, I'm going to get 45 degrees. So this is the cosine of 45 degrees. And we already know, because we've done this in the last two examples, that the cosine of 45 degrees is the square root of 2 over 2. So this is exactly equal to the square root of 2 over 2. Okay, now let's look at two examples where we're going to verify some identities. These are a little bit easier than what we looked at in the last section where we were strictly verifying identities. So let's start with, we have cosine of, we have theta plus pi, okay, is equal to the negative of the cosine of theta, okay. I'm going to flip this because the easier side is here on the right. So I'm going to write the negative of the cosine of theta is equal to the cosine of, you have your theta, okay, plus your pi. Now what I'm going to do is just put my equals over here. I'm just going to slide this over for formatting, okay? Normally they put it in line, but I just want a lot of room. So I'm going to expand this out using the sum identity for cosine. So this would be the cosine of theta, okay, times your cosine of pi. And then remember, this is plus, so you want a minus. So I'm going to go the sine of theta times the sine of pi, okay? Now realize when you work with the cosine of pi or the sine of pi, let's go back to the unit circle. When we look at pi over here, the cosine is -1, okay? And the sine is 0. So let's minimize this. So the cosine of pi is -1. So let's put times -1 like this. And the sine of pi is 0. Okay, so we know if you multiply anything by 0, it's going to be 0, right? So basically, you can get rid of this part right here, right? You'd have -0, which is just gone. So basically, I can say this is equal to the negative of the cosine of theta. And so that matches exactly what we have here, right? Negative cosine of theta, negative cosine of theta. So we're done. Okay, let's look at another example of verifying an identity. This one's just as easy. You have the cosine squared x minus the sine squared x equals cosine of 2x. Now, if it's not immediately obvious what you need to do, remember, if you have 2x, this is the same as x plus x. Okay, so if you're in this section, you're looking to think about the sum and difference identities for cosine. So think about things you can add or subtract. So 2x is x plus x. Okay, so what I'm going to do here, let's just go ahead and put equals here. I'm going to write cosine of x plus x like this, okay? And then I'm going to use my sum identity for cosine. So I'm going to say this is the cosine of x times the cosine of x again, then minus, remember this is plus, this is minus, the sine of x times the sine of x again, okay? So once you write it like this, it's clear that this is going to match, right? Because cosine of x times cosine of x, I can say this is the cosine squared of x, and then minus, I can say sine of x times sine of x is sine squared of x. And now I can see that this side matches this side, right? Cosine squared x minus sine squared x, cosine squared x minus sine squared x. So I can put my check mark there and I'm done. Okay, let's look at one more problem type that you're going to see. So we're asked to find the cosine of s plus t. You might also get the cosine of s minus t. The procedure, the way you do this type of problem is the same, okay? So you have s in quadrant 1 and t in quadrant 3. So they're giving you information about sine. So the sine of s is 3/5. The sine of t is -12/13. So the first thing we want to do is find the cosine of s. So that equals what? And the cosine of t. So that equals what? So one way you could do this is you could use your Pythagorean identity. Remember, cosine, in this case, let's say squared of s plus sine squared of s is equal to 1, okay? So if I plug in for sine of s right here, I can figure out what cosine of s is, okay? So let's scroll down. We'll come back up. So this is going to be 3/5. So remember, this guy is squared. So I'm going to plug in a 3/5 here, and I'm going to square that. So plus, you have your cosine squared of s, and this equals 1. Okay, so 3/5 squared is going to be 9/25. So this is 9/25. So plus, you have your cosine squared s here, and this equals 1. Okay, so I'm going to subtract that away from each side. So I'm going to have the cosine squared of s is going to be equal to, I'll go ahead and write 1 as 25/25. So I have a common denominator, and I'm going to subtract away 9/25, right? I'm just subtracting this away from each side. So 25 minus 9 is going to give me 16. And so I'll say I have cosine squared s is equal to, again, this is 16/25. If I want cosine by itself, I'm going to take the square root of this side. Again, you do plus or minus, but because we're in quadrant 1 for s, it tells us that I just want the principal square root of this guy, so I can erase this and just say I have cosine of s is equal to this. And so cosine of s will be The square root of 16 is 4. The square root of 25 is 5. So you get 4/5 there. So this guy is going to be 4/5. Okay, what about the cosine of t? Well, let's figure that out using the same process. Let's just change up this formula, and I'm going to put t here and t here. It's the same thing. I'm just going to plug in for this, so negative 12/13, but t is in quadrant 3 now, so keep that in mind. So let's come down here, and let's plug in. So we're going to have the cosine squared of t, then plus, and I hate using t because it gets confusing with this plus symbol. So let me use the plus symbol in like black or something so it's clear that this is a plus. I'll even circle it. That's a plus, okay? So then we have the sine squared t is equal to 1. I'm plugging in a negative 12/13 there, so negative 12/13, and this guy's being squared. So if I square a negative, I get a positive. If I square 12, I get 144. If I square 13, I get 169. So I'm going to say this is cosine squared t, and then let me be careful. I'm going to put the plus sign here. Okay, again, that's a plus. And then this is going to be 144 over 169, and then this is equal to 1, okay? I'm going to subtract this away from each side. And before I do that, let me just get a common denominator going. So let's go cosine squared t, okay? This is going to go over here. So I'm going to put equals, and I'm going to do 169 over 169, so that's 1. I just wrote it with a common denominator with this guy. Then minus, again, I'm subtracting this away from each side, 144 over 169, okay? So if I do 169 minus 144, I get 25. So let's scroll down just a little bit, and we'll say that cosine squared of t is equal to, again, this is going to be 25 over 169. Now, because we're going to be in quadrant 3, in terms of this t guy here, cosine is going to be negative. Okay, so I want the negative square root when I do this side. So I'm going to say cosine of t is equal to the negative of the square root of 25 over 169. So let's go ahead and simplify that. So we'll say the cosine of t is equal to, we'll have the square root of 25 is 5. The square root of 169 is 13. So the negative of 5 over 13. Okay, so that's going to be my cosine of t. Okay, so let's put negative 5 over 13 like this. So now that you have all the information, you can find cosine of s plus t. So sometimes they give you sine of one of them and cosine of the other. Sometimes they give you sine of one and then sine of the other. Just depending on the situation you're given, you want to just plug into the identities that you know about, come up with sine, cosine of each of the angles, and then you can go through and use your sum or difference identities depending on the problem. Here we're going to use the sum identity for cosine, and I'm just going to say that we have cosine of our s plus t is equal to, again, if I take my cosine of s, I know what that is. That's 4/5. Then times my cosine of t, that's negative 5 over 13. This is a plus here, okay? So I want to make sure this is a minus. You're going to be really careful with the signs here because sometimes you'll make a mistake with that. So now I want the sine of s, which is 3/5, okay? And then I want times the sine of t, which is going to be negative 12/13, okay? So let's come down here a minute and just process this arithmetic. So I'm going to say this is equal to, if I multiply here, you see that this 5 would cancel with this 5, so basically I have a negative 1 there, okay? So this is basically negative 4 over 13, so negative 4 over 13, and then minus, you're subtracting away. This is 3 times negative 12, which is negative 36, I'm going to write this as, over 5 times 13, which is going to be 65. Now, I canceled here because we were doing multiplication, but it actually would have been smarter if I wouldn't have canceled, because then I'd have a common denominator. So let's undo this and say here we have 4 times negative 5, which is negative 20, okay, over 5 times 13, which is 65. In this particular case, it's better to not cancel because now I have a common denominator, and I can basically say what? I have negative 20 minus a negative 36. Again, you've got to be really careful with that sign. Negative 20 minus a negative 36, which is going to be negative 20 plus 36, which is 16. Okay, let me write this in a different color. So this is going to be 16, and then over, you're going to have 65. So this is going to be your answer for cosine of s plus t. In this lesson, we want to talk about the sum and difference identities for sine and also tangent. All right, so we talked about the sum and difference identities for cosine. Now we're just moving on and talking about the sum and difference identities for sine and tangent. Just something you have to memorize. So if we have the sine of, let's say something like a plus b, again, don't distribute that and think it's sine of a plus sine of b. Okay, it doesn't work that way. You have to use this little formula here. So we're going to say this is the sine of a times the cosine of b plus the cosine of a times the sine of b. So notice how the sine here and the sine here is the same. okay? And then when you get to this one, nothing's going to change except for the sign. So this is a minus and this is a minus. This part right here is the same. So the sine of, let's say, a minus b, now we're going to have the sine of a times the cosine of b minus the cosine of a times the sine of b. So with these, you just have to write them down and just go over it a few times in your mind, use it while you're doing the practice, and you're going to memorize it. Okay. So let's look at a little sample problem here. You saw this in the last section where we would basically rewrite something to get an exact value. You're going to do the same thing here. So we have sine of 165 degrees. So you're going to find two angles basically that are on the unit circle where you already know things about it. So I'm going to do the sine of, let's do 135 degrees. Plus, we're going to go 30 degrees, okay? So basically, if I use my little sum formula that I just talked about, this is going to end up being what? It's going to be the sine of the first guy, so 135 degrees, times the cosine of the second guy, which is the 30 degrees. Then plus, it's the cosine of this first guy, the 135 degrees. And then lastly, times the sine of this last guy, the 30 degrees, okay? So some of you at this point are familiar with the unit circle, others are not. So let's just go really quickly so we can look at this guy just in case you need to pause the video and get the values. When you're looking at 30 degrees, your cosine is going to be square root of 3 over 2. Your sine is going to be 1/2, okay? And then when you look at 135 degrees, your cosine is going to be the negative of the square root of 2 over 2, and your sine is going to be the square root of 2 over 2. So let's come back up and just punch these values in, and we'll basically be done. So I'm going to put equals here, and then basically the sine of 135 degrees is the square root of 2 over 2. So I'm going to say this is the square root of 2 over 2, times, for the cosine of 30 degrees, I've got the square root of 3 over 2, then plus, for the cosine of 135 degrees, I've got the negative of the square root of 2 over 2, and then lastly, for the sine of 30 degrees, I've got 1/2. Okay, so now all we have left to do here is just basically go through and do some basic operations. So we're going to multiply here. So basically square root of 2 times square root of 3, really all I can do is say that's the square root of 6 over 2 times 2, which is 4. Then plus, if I do the negative of the square root of 2 times 1, it's just the negative of the square root of 2. So really I could just change this to minus, okay? And I'll put the square root of 2 over here over 2 times 2 is 4, okay? So basically in this type of situation, generally speaking, you're going to write this with a common denominator. So I'm just going to come down here, get some room going, and I'll just say that this is the square root of 6 minus the square root of 2 all over the common denominator of 4. Okay, so this is the exact value of the sine of 165 degrees. All right, so another type of problem you'll see is something where you're asked to simplify. And basically, you just need to realize here that you can use the difference identity for sine. It's kind of going in reverse here, but basically to solve this problem and to simplify. So if you notice here, you have sine of 3 theta times cosine of negative 2 theta minus the cosine of 3 theta times the sine of negative 2 theta. Okay, so if you notice here, this angle right here and this guy right here, it's the same. You have the sine of this guy and the cosine of this guy, and you have a minus, okay? Then if you look at this guy, it's negative 2 theta and negative 2 theta, cosine of this guy, sine of this guy. So this matches our little formula here. The sine of A times the cosine of B minus the cosine of A times the sine of B. So in other words, you see sine of 3 times theta, and then you see the cosine of 3 times theta over here. And then here you've got this cosine of negative 2 times theta, okay? And then here you've got this sine of negative 2 times theta, okay? So basically what you're going to do is realize that it's this angle right here minus this angle right here. So it's 3 times theta minus a negative 2 times theta, which is going to give us 5 times theta, okay? So that's what that's going to work out to. So I'll just put equals here. I'm just going to put the sine of, I'm going to take this first angle here, this 3 times theta, minus a negative, okay, you have your 2 times theta, okay, that guy right there. And so this would give me, again, if I just combine this, 3 times theta, basically minus a negative is plus a positive, so you would have sine of 5 times theta. All right, additionally, you have the sum and difference identities for tangent. So let's start with the sum guy. So we have the tangent of, let's say, a plus b. This is going to give us, we have the tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. And what's going to happen when we change over to this difference guy, the signs here are just changed. So before, when this was plus and this was minus, okay? Now that this is minus and this is plus. So again, just something you have to write down and just keep practicing with, and you will commit it to memory. All right, let's take a look at an example with this guy. So suppose you're given the tangent of pi over 12. So if you want to find the exact value, again, one way you can do this is by using these sum and difference identities. So I like to work with degrees when I do this. It's just easier versus me trying to figure out what I need to add and subtract using fractions. So if you can do this with fractions, just skip this step that I'm about to do. But I'm going to convert this first into degrees, and then you can go back to radians, okay? So I'm going to go pi over 12 times, I'm going to go 180 degrees over pi. And then basically, this would cancel with this and give me 15 degrees, okay? This is going to cancel out. So pi over 12 in terms of radians is the same as 15 degrees. Okay, so now that I got this in terms of degrees, what two angles could I add or subtract to get 15 degrees? Well, one thing you could do is 45 degrees minus 30 degrees, okay? So I could write this as the tangent of 45 degrees in terms of radians is going to be pi over 4, okay? And then minus, if I think about 30 degrees in terms of radians, it's going to be pi over 6. Okay, so pi over 6. All right. So the next thing I want to do before I even use my formula, I know I'm going to need the tangent of pi over 4. So I know I need the tangent of pi over 4. And I know I need the tangent of pi over 6. Let's go back to the unit circle. I know some of you have this memorized, some don't. So let's just go back to the unit circle. So if we're looking at our pi over 4, or 45 degrees, we have square root of 2 over 2 and square root of 2 over 2. So that means the cosine and the sine are the same. And basically, the tangent is the sine divided by the cosine. And since it's the same number, right, the same number divided by itself is going to give you 1. Okay, so we know that, and I'll just write this down. The tangent of pi over 4 is just going to be 1, okay, because you have square root of 2 over 2 divided by square root of 2 over 2, so that gives you 1. Then the tangent, if I think about for pi over 6, this is going to be what? Well, you want the sine, which is 1/2, divided by the cosine, which is the square root of 3 over 2. So basically, I would flip this guy, okay, because I'm dividing fractions. So let's put the 2 up here and the square root of 3 over here, okay? And then basically, the 2's cancel, and I have 1 over the square root of 3. So 1 over the square root of 3. Of course, we're going to rationalize this. So I'm going to multiply this by the square root of 3 over the square root of 3. And so this is going to give me the square root of 3 over 3. Okay, so let me write this in a more compact way. So square root of 3 over 3. Let's copy this, okay? And let's go back, and let's just paste this in here real quick. And so this is 1, and this is square root of 3 over 3. Okay, so square root of 3 over 3. Okay, so now that we figured that out, we can use our little difference identity. And for this guy right here, let me put equals. It's going to be, and I'm just going to slide this off to the side for 1 second. So this is going to be the tangent of the first guy. So the tangent of pi over 4 is going to be 1. So it's going to be 1, then minus the tangent of the second guy. So minus the tangent of pi over 6, which is the square root of 3 over 3. Then this is over. Remember, you have your 1. The sign is different here, so it's going to be plus. You're going to multiply them together, right? So the tangent of pi over 4 times the tangent of pi over 6. So basically 1 times this guy. So it would be plus the square root of 3 over 3. Okay, so let's get rid of this. We don't need it anymore. Now, basically, you have a lot of different options here when it comes to simplifying, okay? I am going to choose to basically multiply the numerator and denominator of this guy by 3, okay? So this is going to get distributed here and here. This is going to get distributed here and here. So what is this going to give me? Let me scroll down and get some room going. So 3 times 1 is obviously 3. And then minus, this would cancel with this, and I'd have the square root of 3 there, okay? So we'll put this over here, and I'll kind of undo this real quick, just showing that. Over here, 3 times 1 is 3, then plus, again, the 3's would cancel there, and you'd have the square root of 3. Okay, so now this is a little bit simpler, but really, in order to go anywhere, what I'm going to do, remember, if you have a radical down here, you have this plus here, if this is binomial like this, then basically what you can do is you can multiply by the conjugate, okay? So I can wrap this and I can wrap this. So I'm going to multiply this by, I'm going to have 3 minus, okay, I'm changing the sign from plus to minus, then the square root of 3, okay? Then over, you would have 3 minus the square root of 3. Again, this is just a complex form of 1. When you multiply these guys together, you're just going to do the first guy squared minus the last guy squared. Remember, the middle 2 guys are going to drop out. Okay, so let me make sure I got my equal sign going. So put that in there. Let's keep going. All right, so in the top, realize this is 3 minus square root of 3 quantity squared. So I can use a formula on that. Take the first guy and square it, so 3 squared. And then this is minus, so minus, it's 2 times the first guy, which is 3, times the last guy, which is square root of 3, and then plus the last guy, square root of 3 squared is 3, okay? You can simplify this right now. 3 squared is 9. Then basically 2 times 3, you know that's 6, so you'd have minus 6 times the square root of 3, and then plus 3. Now, 9 plus 3 is 12, so let me just go ahead and put this as 12 minus 6 times the square root of 3, okay? So we have that, and I can even shorten this a little bit and put this like this. Now down here, all I need to do is square the first guy, so 3 squared is 9, and then subtract away, if I square this guy, square root of 3 squared is just 3. Now I can just perform this operation. 9 minus 3 is just 6, okay? Now we're not done because notice that you have 12 here, which is divisible by 6, 6 here, which is divisible by 6, and 6 here, okay? So what I'm going to do is I'm just going to factor a 6 out from the numerator. So this is going to be 2 minus the square root of 3, okay, over 6 down here. And now we're done, right? We cancel this, and I end up with 2 minus the square root of 3 as my answer for the tangent of pi over 12. All right, let's look at an example where we're going to verify an identity. So we have the cosine of beta is equal to the sine of, we have this pi over 6 plus beta, and then plus we have cosine of, we have pi over 3 plus beta. Okay, so basically we always want to work on the more complex side. Obviously the right side is way more complex. So I'm just going to put equals over here. Okay, and normally we line this up, but I want to give myself lots of room. So basically what I'm going to do is I'm going to use my sum identity here and my sum identity here. Okay, so I'm going to first say that I have the sine of this pi over 6 times the cosine of this beta, okay? Then plus, okay, so now I'm going to do the cosine of this guy right here. So let me change color. So I'm going to go the cosine of this, in this case, pi over 6, and then times you have your sine of beta. So your sine of beta. Now, additionally, I want to do the same thing with this cosine guy. So I'm going to put plus here. Remember how to do this. I'm going to go cosine of this guy. So cosine of pi over 3, and then times the cosine of the next guy, so cosine of this beta here. And then if this is plus, it's going to go minus, right? So the signs are going to be different there. And then now I'm going to do the sine of this guy, sine of pi over 3, times the sine of beta. Okay, so now what we want to do is think about what can we replace? Well, think about the fact that you have the sine of pi over 6 and the cosine of pi over 6. So coming back to my unit circle, again, when we think about pi over 6, the sine is a half and the cosine is square root of 3 over 2. So let's just write this down. So we have the sine of pi over 6 is 1/2. And we had the cosine of pi over 6. That's going to be the square root of 3 over 2. Now, additionally, we were also working with this pi over 3, right? So we need the sine and cosine for that guy as well, okay? So the cosine for pi over 3 is going to be 1/2. And the sine for pi over 3 is going to be the square root of 3 over 2. Okay, so let's go ahead and grab this guy, and we're going to cut it away. And I'm just going to come down here real quick and paste this in so we have it. So let's just replace the sine of pi over 6 with 1/2 and the cosine of pi over 6 with square root of 3 over 2. Okay, so let's come up here. So let's go ahead and put equals. Instead of the sine of pi over 6, I'm going to put 1/2 and then times my cosine of beta. Okay. Plus, for this guy right here, I'm going to put the square root of 3 over 2. So the square root of 3 over 2 times my sine of beta, okay? And so let's get rid of these two right here. We don't need them anymore. And let me scroll down a little bit, and I'll drag these up into our visual range, okay, so we can work with them. Let's come back up here real quick. So now we want to replace this cosine of pi over 3. So I'm going to put plus. This guy is going to be 1/2. And then times your cosine of beta. Okay, so let's get rid of this. And then lastly, I'm going to put this minus here. We have the sine of pi over 3, which is the square root of 3 over 2. So let's get rid of this. And this is times our sine of beta. Okay, and sometimes I put multiplication signs and sometimes I don't. You don't need it. Sometimes I just put it there. Okay, so let's scroll down a little bit, get a little bit more room going. Let's think about what we can do. So we'll notice here that this guy right here, okay, and this guy right here, those can be canceled, right? You have the square root of 3 over 2 times the sine of beta, and then you have the negative of that. So I can just cross that out. Those are gone. So basically I can say this is 1/2 times cosine of beta plus 1/2 times cosine of beta. So let's stop for a second. Remember what we're trying to get. We're trying to just get the cosine of beta. So basically, if you have a half of something plus another half of something, you have one of that thing. You basically have a common denominator here, right? You could say this is the cosine of beta plus the cosine of beta over 2, right? And you have 2 of this. So let's go ahead and come down here and just say that we have basically 2 times the cosine of beta over 2. And we can cancel that. And lastly, we will say that we have the cosine of beta, okay? And so we've verified our identity. All right, let's look at one other type of problem here. We're going to be asked to find the sine of theta plus beta, the tangent of theta plus beta, and the quadrant of theta plus beta. So a very common type of problem. Unfortunately, they do take a while to work out. So let's go ahead and come down here. And for this one, I'd like for you to try it on your own before we even go. We did a similar problem with cosine in the last lesson. So we have sine of theta is equal to 4/5. We have the cosine of beta, which is equal to the negative of 5/13. And then we're told that theta is in quadrant 2 and beta is in quadrant 3. Okay, so how do we figure this out? Well, what we need is the cosine of theta. So that equals what? Okay, that equals what? And we need the sine of beta. So that equals what? Okay, if we have these two pieces of information, then we can use our little formulas that we've been talking about in the lesson. Okay, so basically, how do we get this? If we know the sine of theta is 4/5, well, I can start off by saying, well, the sine squared theta plus the cosine squared theta equals 1. Okay, remember your Pythagorean identity. So I can plug in here a 4/5, and that's going to be squared, right? So 4/5, and this is going to be squared. So this ends up being 16 over 25 plus the cosine squared theta is equal to 1. Again, I'm just going to move this over here. So let me scroll down a little bit. I'm just going to say that I have cosine squared theta is equal to, if I subtract this away from each side, I'd have 1 minus 16 over 25. If I make this as 25 over 25, then basically 25 minus 16 is 9, so you would have 9/25, okay? But now the issue is I want cosine of theta, not cosine squared theta. So basically I need to square root each side. Remember, you get plus or minus over here, and then based on what quadrant you're in, that's how you decide what sign you're going to use. Now we're told that theta is in quadrant 2, okay? And in quadrant 2, cosine is negative. So I'm going to go cosine of theta is equal to, I'm going to use the negative of the square root of 9 over 25. And of course, this is going to end up giving me the cosine of theta is equal to negative square root of 9 is 3, and then the square root of 25 is 5. So negative 3/5, okay? So let's take this up. So we're just going to cut this away. And actually, I'll just write it in here. So I'll put negative 3/5. So that's the first piece of the puzzle. So now we need to find the sine of beta. I'm going to use the same thought process. So the cosine of beta is the negative of 5/13. So again, we have the sine squared, in this case beta, plus cosine squared beta is equal to 1. And for cosine squared beta, remember for cosine itself, I'm plugging in a negative 5/13, and this guy's being squared. Don't forget to square it. Okay, so if I square this guy, I'm going to get 25 over 169. So I'm going to have sine squared beta plus this guy here equals 1. Same thing, I'm just going to move it to the other side. So I'm going to say sine squared beta is equal to, let me go ahead and put this as a common denominator. So 169 over 169, same thing as 1. Then minus this guy over here, I'm just moving to the other side. So minus your 25 over 169. And so the sine squared of beta is equal to 169 minus 25 is 144. So you have 144 over 169. Now, we said that beta was in quadrant 3, and in quadrant 3, sine is going to be negative. So I'm going to say the sine of beta is equal to the negative of the square root of this guy, so the 144 over 169. So the square root of 144 is 12, the square root of 169 is 13. So I'll go ahead and say the sine of beta is equal to the negative of 12/13, okay? So the negative of 12/13. So let's put this up here, the negative of 12/13. Okay, so we are officially ready to answer this part up here, the sine of theta plus beta, okay? So basically, you would have the sine of theta plus beta is equal to the sine of theta, which is 4/5, multiplied by the cosine of beta, which is negative 5/13, okay? Then plus, you have your cosine of theta, which is negative 3/5, and then times your sine of beta, which is negative 12/13, okay? I'm going to wrap this in parentheses so I don't make a silly sign mistake. Now, in a lot of cases, you'll notice when you're multiplying here, you can cross cancel. Here, notice that you have 5 times 13 and 5 times 13. So don't cancel this because you're going to want to have a common denominator. I make that mistake all the time, so I'm just going to stop you from doing it. Okay. So basically, 4 times negative 5 is negative 20. And this is over. 5 times 13 is 65. Then plus, negative times negative is positive. So 3 times 12 is 36. Over 5 times 13 is again 65. Okay. So to finish this up, I'd have negative 20 plus 36, which is 16, and then over the common denominator of 65. So sine of theta plus beta is 16 over 65. So let's just erase all this work. So sine of theta plus beta is equal to 16 over 65. Okay, so how do we get the tangent of theta plus beta? Well, first, I need the tangent of theta, and I also need the tangent of beta. So how do I get that? Remember, for the tangent, you divide the sine by the cosine. So if I think about, let me go down here because we're going to forget stuff. So if I want the tangent of theta, it's going to be the sine of theta, which is 4/5. So 4/5 divided by the cosine of theta, which is negative 3/5. Again, we're dividing fractions. So flip this guy. I'm going to multiply by the reciprocal. So times 5/3. This cancels and I get negative 4/3. Okay. So let me just scooch this down. So this is going to be negative 4/3, okay? And then we want the tangent of beta. So how do we get that? Same way. So I'm going to do negative 12/13. Let me change my ink here. And then times, over here, I'm going to flip this. So I'm going to do negative 13/5. And again, stuff's going to cancel. So this cancels with this. Negative cancels with negative. That's positive. So you have 12/5, right? So this is positive 12/5. Okay. So let me drag this back up. So let's cut this away. And let's paste this in here, okay? And let's see if we can figure out what the tangent of theta plus beta is. Again, I take the tangent of the first guy. Let me write this off to the side. So the tangent of theta plus beta, okay? So the tangent of the first guy, which is negative 4/3, then plus the tangent of the second guy, which is 12/5. This is over. We want 1, again, this is plus because it's the same as this. This is going to be minus, right? So this is always different. This is always the same. So 1 minus, multiply the two together. So it's negative 4/3 times your 12/5, okay? And let me get rid of this now. We don't need it just so we have some room. So let's move this over. Let's move this over. Okay, put this over here. And I'm going to drag this up here a little bit. And I'm just going to scroll down a little bit. We'll come back up in a second. So the best way to do this, let me just put equals over here. I'm not going to get a common denominator yet. So I'm going to go negative 4/3 plus 12/5 over. For this one, I'm just going to multiply. Negative 4 times 12 is going to be negative 48. And this is over. 3 times 5 is 15. And you've got 1 minus this, okay? So what is the LCD if I think about all the fractions involved? If I think about 3, and that's a terrible 3, so let me make that better. So if I think about this 3 here, let me get off the marker mode. So this guy, the 3, the 5, and the 15. Well, it's 15, right? So the quickest way to do this, in my opinion, is to multiply the top and bottom by 15, okay? So I'll save you a lot of time. We'll go ahead and distribute this here, and then here, and here, okay? So first off, minus a negative is the same as plus a positive, okay? You can just change that right away, so you have to deal with it. And you'd have 15 divided by 3 is 5. 5 times negative 4 is going to be negative 20. Then 15 divided by 5 is 3. 3 times 12 is going to be 36. So plus 36. You can go ahead and do that if you want. You know that's going to be 16. So this is 16. This is over. If you multiply 15 by 1, that's 15. And then 15 divided by 15 is 1. So you just have plus 48 there. So what's 15 plus 48? It's going to be 63. Okay, so this guy's going to be 16 over 63. And I could put equals there. But really, I'm just going to erase all of this. And I'll just put a little line here. Put the tangent of theta plus beta is equal to, and let me just paste that in, my 16 over 63. Okay, so sine of theta plus beta is 16 over 65. Tangent of theta plus beta is 16 over 63. Now we want to think about, and I can just get rid of this, we want to think about the quadrant of theta plus beta. Well, I just want you to think about the sine. The sine of theta plus beta is positive, right? So sine is positive, okay? The tangent of theta plus beta is also positive. So the tangent is also positive, okay? So where is sine positive and also tangent positive? Remember, you can always draw your little coordinate plane, and I know this is a terrible freehand draw, but it's all students take calculus, right? All, you have your sine, your tangent, and your cosine, okay? So if we think about sine, it's positive in quadrants 1 and 2, and tangent is positive in quadrants 1 and 3. So the only guy that meets both criteria here is going to be quadrant 1, okay? So the quadrant of theta plus beta, okay, is going to be 1. So this is going to be, we'll say, is in quadrant, I just probably put a capital Q, so quadrant 1. In this lesson, we want to talk about the double angle, the product of sum, and also the sum-to-product identities. All right, so at this point, we've learned quite a few of the trigonometric identities. We just keep adding on to the ones that we already know. I'm just going to pop open this little worksheet here real quick. So this is the whole worksheet. If you go back up to the top, this is all the stuff we've already learned. So all of these guys we've already talked about. And now we're getting into the double angle identities. And then again, we'll talk about the product of sum and the sum to product at the end of the video. But right now we're going to focus on these. So you can either pause the video and write these down really quickly, or you can use the worksheet that's been provided. Okay, so the problem we're going to look at here is just going to be asking to find some trigonometric function values. We have the cosine of theta is equal to 2 times square root of 2 over 3. And we have that sine of theta is greater than 0, or you could just say positive, right? So basically, if it's cosine of theta is positive and sine of theta is positive, that tells me that we're in quadrant 1, right? So we can say here that theta is in quadrant 1. So we're going to need that piece of information. Now, what we're going to be asked to find is the cosine of 2 times theta. So we want to find the cosine of 2 times theta. We also want to find the sine of 2 times theta, okay? And then also we want to find the tangent of 2 times theta. And of course, once you have these, you can use your reciprocal identities to find the other ones. I'm just going to do these 3 right here. All right, so the first thing I'm going to do, what I'm going to focus on is finding the sine of theta and the tangent of theta, okay? And then we're going to use our identities to find the cosine of 2 times theta, the sine of 2 times theta, and the tangent of 2 times theta. Okay, so if I'm given cosine of theta, how can I find sine of theta? Again, we've done this a million times. One way we can do this, we can say that cosine squared theta plus our sine squared theta is equal to 1. Okay, so our Pythagorean identity, something we're really used to working with at this point. So for this guy, I'm going to plug in this 2 times square root of 2 over 3. And I'm just going to square this guy. Okay, let me just copy this and go to a fresh sheet because we're going to run out of room here. So let's come down here and just paste this in so we have lots of room. And then I'm just going to say plus my sine squared theta is equal to 1. Okay, so from here, if I squared 2, I would get 4. If I squared the square root of 2, that's 2, okay? And if I squared 3, I would get 9. So basically 4 times 2 is 8, so this is 8/9. Then plus your sine squared theta is equal to 1. I'm just kind of drag this up here. And from here, I'm just going to say that I have sine squared theta is equal to, I'm going to subtract 8/9 away from each side of the equation. So I'm going to put 1 minus 8/9. Okay, and again, all I did was subtract it from both sides of the equation. And so now what I have is my sine squared theta is equal to, if I write this as 9 over 9, so I have a common denominator, and then I'm subtracting away this 8/9 here, this on the right-hand side is going to be 1/9. So I would say sine squared theta, okay, is equal to 1/9. Okay, now from here, in order to get rid of this kind of squaring operation, I'm going to take the square root of each side. Normally, again, you do the plus or minus on the right-hand side, but because we're in quadrant 1, I know that sine is positive, so I want the principal square root. So I'm just going to say that the sine of theta here is going to be the principal square root. Let me show this fully. So the principal square root of 1/9, okay? So the sine of theta is equal to square root of 1 is 1, square root of 9 is 3, okay? So let me just write this up here that the sine of theta, so the sine of theta is equal to 1/3. Okay, and we'll come back up and we'll use this. Let's come back down here for a second. Let me erase all of this. So I'm also going to need my tangent of theta. So the tangent of theta, we all know that this is the sine of theta divided by the cosine of theta. So the sine of theta we just found was 1/3, okay? And the cosine of theta, if I go back up here, it's 2 times square root of 2 over 3, okay? But because I'm going to be dividing fractions, I'm going to go ahead and flip that guy and multiply. So this is 3 over 2 times square root of 2, okay? So what's going to happen is the 3's are going to cancel, and I have 1 over 2 times the square root of 2. I want to rationalize the denominator here, so I'm going to multiply by the square root of 2 over the square root of 2, okay? So basically, if I think about what I'm going to have here, in the numerator, it's just the square root of 2. In the denominator, it's 2 times the square root of 2 times the square root of 2. Square root of 2 times square root of 2 is 2, so 2 times 2 would be 4, okay? So the tangent of theta is the square root of 2 over 4. So let's just write this here, that the tangent of theta is the square root of 2 over 4. Okay, so now let's go ahead and find the cosine of 2 times theta, the sine of 2 times theta, and the tangent of 2 times theta. So for the cosine of 2 times theta, let's go back to our little sheet here. So we have cosine of 2a. You could plug in theta for a or x or whatever you want to do. It's cosine squared of a minus sine squared of a. So that's pretty easy to do. So let's make a little border here. And actually, I'll probably be better off just going to the other sheet. So we'll say cosine of 2 times theta is going to be equal to cosine squared theta minus sine squared theta. Okay, so I'm just going to plug in. So cosine of 2 times theta is equal to, remember our cosine of theta was 2 times the square root of 2 over 3. Okay, this guy's going to be squared. Then minus, remember our sine squared theta, you might remember this was 1/9, but basically sine of theta was 1/3. Right, so I'm going to put 1/3 here and square it, and that's going to give me 1/9. Okay, so if you remember from earlier, when we squared this, we got 8/9, right? Because 2 squared is 4. Square root of 2 squared is 2. 4 times 2 is 8, okay? And basically 3 squared is 9. So this is 8/9 minus, let me put equals over here. I'll just write the whole thing out. So cosine of 2 theta is equal to 8/9 minus, again, if you square this, you get 1/9, okay? So this gives me a final result here of 7/9. So this is my cosine of 2 theta. Okay, so let's come up here and put that our cosine of 2 theta is equal to 7/9. Now, if you're asked for the secant of theta, you would just flip that and get 9/7. Okay, but we're not asked for that here. So then now I want to find the sine of 2 theta. Okay, so what's this going to be equal to? Let's come back down here. So what is my sine of 2 theta? Well, let's go back to our worksheet here, and we see that the sine of 2a is equal to 2 times the sine of a times the cosine of a. So again, you could just plug in. You could say the sine of 2 times theta is equal to 2 times the sine of theta times the cosine of theta. So this is equal to 2 times the sine of theta times the cosine of theta. Well, again, we know the sine of theta is 1/3. So this is 1/3. And we know the cosine of theta is 2 times the square root of 2 over 3. So let me put my 2 in here, and let me put sine of 2 theta like this. So let me write this again over here. Let me put sine of 2 times theta is equal to, basically I'm just going to multiply across. 2 times 1 times 2 is going to be 4, then times the square root of 2 over 3 times 3 is 9. Okay, so sine of 2 theta is equal to 4 times square root of 2 over 9. So let me just move this down a little bit, or actually I can put it over here. So the sine of 2 times theta is equal to 4 times the square root of 2 over our 9. And again, you could flip this to find the cosecant of 2 theta, okay? But again, you'd have to rationalize the denominator there. We're not asked for that here, so we're not going to do that. Okay, so lastly, we want the tangent of 2 theta. So how do we find this? Well, essentially, all I need to do is take this guy right here and divide it by this guy right here, or I can use my formula. So let's see this both ways. So for the tangent of 2 times theta, the first way we're going to do it, probably the easier way, you basically take your sine of 2 times theta, which again is 4 times square root of 2 over 9. So 4 times square root of 2 over 9. We're going to multiply it by the reciprocal of this cosine of 2 theta, which is 7/9. So if you flip that, you get 9/7. Again, I'm flipping that because if you're dividing fractions, you take the first fraction, multiply by the reciprocal of the second. So this is going to cancel. We're going to be left with 4 times square root of 2 over 7. So that's the quickest way. That's the way you probably want to do this. So let's come back up here. So 4 times square root of 2 over 7. Now the other way, and I just want to show you this with the identities. It's a little bit longer, but I think you should see it. Let's pop this open. We have the tangent of 2a is equal to 2 times the tangent of a over 1 minus tangent squared of a. Okay, so let's come down here and say that the tangent of 2 times theta is equal to 2 times the tangent of theta over 1 minus tangent squared theta. Okay, so what is the tangent of theta? If we go back up, the tangent of theta was square root of 2 over 4. So let's come back over here. And I'm just going to put this over here. So the tangent of theta was the square root of 2 over 4. So we would start with, and let me just put equals over here, 2 times this guy right here, which is square root of 2 over 4, okay, over 1 minus tangent squared theta. So I'm just going to square this guy. So if I square, let me just show this. So if I square the square root of 2, I'm going to get 2. If I square 4, I get 16. Okay, so I'm going to go ahead and say this is multiply across. I'll say this is 2 times square root of 2 over 4 over, you would have 1 minus, again, if I square root of 2, I get 2. If I square 4, I get 16. Okay, let me scroll down and get a little bit of room going here so we can see what's going on. It's probably quicker for me to just multiply this by 16 over 16. That will cancel all my denominators. So 16 times this guy, the 16 would cancel with the 4 and give me a 4. So you'd have 4 times 2, which is 8. So let me put 8 times the square root of 2 here. And then down here, 16 times 1 is 16. And then minus 16 times this guy right here. The 16s would cancel, so I just have 2. Okay, so that's probably a quicker way versus what I was going to do, which is basically to work with these guys individually. Okay, so now 16 minus 2 is going to be 14. So this is 8 times square root of 2 over 14. Okay, and basically I can cancel this 8 and this 14. They're each divisible by 2. So this is going to be 4 and this is going to be 7. Right, so we get 4 times square root of 2 over 7. And you see that's what we got before, right? So it's much quicker if you have the sine of 2 times theta and the cosine of 2 times theta to just work with that versus using the formula. But sometimes you're told to show it on a test or something like that. So if you do it the alternative way using the double angle identity, it works the same. All right, so now we're going to look at a similar problem, but it's going to go in reverse. So now we're given the cosine of 2 times theta. In this case, it's equal to the negative of 7 over 25. We're told that theta is in quadrant 4. Now, you might be thinking that the cosine of theta should be positive in quadrant 4. But remember, this is the cosine of 2 times theta. Okay, so not the cosine of theta. This is the cosine of 2 times theta. So what we're going to find here is the 6 trigonometric functions, those values for theta. Okay, so basically, I would start off by finding my sine of theta. I can then use that to find the cosine of theta. And from those two guys, I can basically find all the rest, right? Really easy to do. So how am I going to find the sine of theta given this information? Let's go back to our little worksheet, or you could say handout. And basically, if you look here, you have this guy right here, which would work pretty nicely. You have the cosine of 2a is equal to 1 minus 2 times sine squared of a. So let's use that. So we have the cosine. Let me do this on another sheet. So we have the cosine of 2 times, in this case, I think it was theta. So it was theta is going to be equal to 1 minus 2 times sine squared theta. Okay. Now I know what cosine of 2 times theta is, right? I'm given that as negative 7 over 25. So just plug in for that. So we're going to say this is negative 7 over 25, okay, is equal to 1 minus 2 times sine squared theta. All right, so from here, let's go down a little bit and get some room going. I'm going to basically flip this around. I want what I'm solving for on the left. So I'm going to add 2 times sine squared theta to both sides. So I would have 2 times sine squared theta, okay, is equal to, I'm going to leave this guy over here, and I'm going to add 7/25 to both sides. So basically, I'm going to have 7 over 25 plus 1 over here, okay? So all I did was just kind of swap things around. It's just adding and subtracting the same thing to both sides of an equation, which is legal, okay? So basically what I want to do at this point is go ahead and add 7/25 plus 1. So I'm just going to write this as 25 over 25. And this would give me 32 over 25, okay? So I would have over here 2 times sine squared theta is equal to 32 over 25. I have this 2 that I want to get rid of, so I can multiply both sides by a half. So let's multiply this side by a half and this side by a half. And basically, this is going to cancel out. And over here, this would cancel with this and give me 16. Okay, so now let me keep scrolling down here. We have that sine squared theta is equal to, you have 16 over 25. Okay, so you have to take the square root of each side. Again, if we go back up, we are told that theta is in quadrant 4. we know that the sine of theta, if it's in quadrant 4, is going to be negative, right? Because sine is positive in quadrants 1 and 2. So if we come back here, what I want to do is take the negative square root of this right-hand side. So I'm going to say the sine of theta is equal to, I'll go the negative of the square root of 16 over 25. So the sine of theta is equal to the negative of, square root of 16 is 4, square root of 25 is 5. So sine of theta here is equal to the negative of 4/5. Okay, so let's go back up and let's put right here, the sine of theta is equal to negative 4/5. All right, so how do we find the cosine of theta and all the rest of them? Well, basically at this point, we can just use our regular identities that we've been working with. I can use the Pythagorean identity to get this guy. So we know that sine squared theta plus cosine squared theta equals 1. So I'm going to have my negative 4/5 for my sine of theta. I'm going to square that plus my cosine squared theta. This equals 1. Okay, so if we square this, we get our 16 over 25. Then plus our cosine squared theta. This equals 1. Let's subtract this away from both sides. So I'm going to have cosine squared theta is equal to, I'm just going to write this as 25 over 25 to speed this up. And over here, I'm going to put minus. Again, I'm subtracting this away from each side. So 16 over 25. Okay, so from here, it's pretty easy. We have cosine squared theta is equal to 25 minus 16 is 9. So this is 9 over 25. Okay, so we're in quadrant 4. Cosine is going to be positive in quadrant 4, okay? So what I want to do is take the principal square root of this right-hand side. So I'm going to say the cosine of theta is equal to the principal square root of 9 over 25. So now let's finish this up and say the cosine of theta is equal to, square root of 9 is 3, square root of 25 is 5. So this is 3/5. So let's come back up, and this will be 3/5, okay? So then the tangent of theta is found by what? You basically take this guy right here, this negative 4/5, and you multiply by the reciprocal of this 5/3, okay? And this cancels, and you get negative 4/3. So this is negative 4/3. And then the other guys are found with the reciprocal identities. So let's just go ahead and do the cotangent really quickly. So the cotangent of theta, that's found by flipping this, so it's negative 3/4. Then if I want, let me scroll down just a little bit. If I want the cosecant of theta, that's found by flipping this sine of theta. So this is negative 5/4. And then lastly, if I want the secant of theta, that's found by flipping the cosine of theta. So that's going to be 5/3. Okay, let's look at two examples of verifying some trigonometric identities. You always want to get practice doing this because it keeps coming up again and again and again. And the more you work on it, the better you're going to be when you need it for calculus. Okay, so we have the cotangent of x times the quantity 1 minus the cosine of 2x is equal to sine of 2x. So the first thing I'm going to do is flip this. I'm going to put sine of 2x here basically on the left-hand side for formatting. And I'm going to put is equal to, let's just go ahead and put cotangent of x times the quantity 1 minus the cosine of 2x. Okay, so how can we approach this problem? The first thing I always like to do, if I see something like the cotangent of x or the tangent of x, the first thing I'll try to put things in terms of sine and cosine. It doesn't always work that way, but in this case, it will work out this way. So we have the sine of 2x is equal to, I'm going to go ahead and say that the cotangent of x is the cosine of x over the sine of x. And this is times the quantity 1 minus the cosine of 2x. Now, you have 1 minus something, and I want you to look at the identities here. If you go back here, notice you have this 1 minus 2 times sine squared of a here for the cosine of 2a. Okay, so if I plug this in here, I can get that 1 to drop out. So I'm going to go ahead and write this as the quantity, make sure you use parentheses here, 1 minus 2 times sine squared, in this case, of x. Okay, so you need parentheses there because you're subtracting the whole thing away. And what I'm going to have here, let me put my equals over here. And I know normally you line this up, but I want a lot of room, so I got to do it over here. So cosine of x over sine of x times, in this case, you could go ahead and write this as 1 minus 1 plus 2 times sine squared x. And see how the 1's are going to cancel out there? So let's scroll down a little bit more, get some room. I'm going to say is equal to, I'm going to go cosine of x over sine of x times 1 minus 1 is 0, right? So that's gone. You have 2 times sine squared x. Now you can do some canceling, right? This is going to go away. I can get rid of one of these, right? So basically, what I can do here is say that I have 2 times sine of x times the cosine of x. Now let's stop for a minute. If we go back up, we're trying to get the sine of 2x. Okay, so that's what we want. So is there an identity that matches that? If we go back, we have that the sine of 2a is equal to 2 times sine of a times cosine of a. So we're basically done, right? We can basically replace this right here with the sine of 2x. So we can go ahead and put a big fat check mark there to show that we're done. Okay, let's look at another example. Again, I just want to do a lot of examples of these. So we have 1 plus the cosine of 2x is equal to the cotangent of x times the sine of 2x. Okay, so which side is more simple? I would say that because this has cotangent involved and this just has cosine, right? This is cotangent and sine over here and you have cosine. So I would not mess with the left-hand side. I would mess with the right-hand side. So I would put equals over here and I would change this into, again, cosine of x over sine of x just to get started. Again, it doesn't always work out that way. And then you have the sine of 2x. So be careful here. Don't go through and cancel this with this immediately because this is not like having sine squared of x, right? This is sine of 2x. So you basically want to use your little formula where the sine of 2 times x is basically 2 times the sine of x times the cosine of x. So let's put cosine of x over sine of x. And let's say basically over here we have, instead of sine of 2x, I'm going to put times 2 times the sine of x times the cosine of x, okay? So now we can cancel this with this. Again, don't cancel it here. That's not correct. You have to cancel here when it's sine of x and sine of x, or if you had sine squared of x or something like that, then you can cancel. But sine of 2x, you're not going to be able to cancel with sine of x. It doesn't work that way. So let's come down here a little bit, okay? And let's go ahead and put our equal sign. And now basically what I'm going to have is 2 times cosine squared of x. So you might think you have a little stopping point here because I'm trying to get 1 plus cosine of 2x. But again, if you look at your identities, you're going to find something that can match. So if I come back here, right now we have 2 times cosine squared of x, okay? If I add 1 to each side, it's exactly what I'm looking for, right? Cosine of 2a plus 1 is equal to 2 times cosine squared of a, okay? So basically I'm just going to replace this guy right here with its alternative form. I'm going to say this is equal to 1 plus the cosine of 2x. Okay, so straight from your identities handout, we'll go ahead and put a check mark there because we're done. Okay, let's look at some problems that involve the product to sum identities and also the sum to product identities. These come in a variety of forms. Sometimes you're asked to find the exact value. Sometimes you're asked to simplify. These guys are really easy to work with as long as your teacher allows you to have the sheet in front of you. Otherwise, you do have to memorize them, okay? So what we have here is 2 times sine of 105 degrees times cosine of 75 degrees. So basically this is a product, okay? And we're going to want to change this into a sum to get an exact value. So let's go to our little worksheet here. And there's quite a few of these. So let's go to basically where we have our sine of a times our cosine of b like this. This is going to be 1/2 times, inside these brackets here, you have the sine of a plus b plus the sine of a minus b, okay? So let's just put this down here, and I'll just write it out really quickly for you. So basically, if we have the sine of a times the cosine of b, okay, which is what we have right here, then basically this is going to be 1/2 times the sine of, let me put this in brackets, a plus b, okay? And then you have your plus your sine of, let me slide this down, this is not going to fit. So your sine of your a minus b, okay? So let's close that down. So the first thing is you can cancel this immediately by saying you have 2 times this 1/2 here, or you can cancel it later. It doesn't really matter. You can put this as 2 times, and then you can put brackets here, and then put 1/2, and then put more brackets, and then put your sine of, what's a in this case? That's going to be 105 degrees. What's b? That's 75 degrees. So 105 degrees plus 75 degrees is 80 degrees, okay? And let me just write this like this. I'll just put sine of 80 degrees plus the sine of, what's a minus b? What's 105 degrees minus 75 degrees? That's going to be 30 degrees, okay? So you can put these brackets here. Again, it's not going to matter because when 2 gets multiplied by 1/2, it's basically going to be 1, right? So it's basically gone. So we can just say that we have the sine, and I put 80 degrees, this should be 180 degrees. So the sine of 180 degrees plus the sine of 30 degrees. So at this point, you should be very familiar with your unit circle. The sine of 30 degrees you should know is 1/2, and the sine of 180 degrees you should know is 0. So this basically turns into 0 plus 1/2, which gives me 1/2, okay? So just a little formula where you start off with something that looks kind of hard to work with, you plug some things into the formula, and you get an exact value of 1/2. Okay, let's look at an example of what we call a sum to product. Here we're just going to be asked to simplify. So you have the cosine of 13 theta minus the cosine of 5 theta, okay? So basically we want to change this into a product. So let's go ahead and go back and look at now, if we come down here, we have the sum to product identities. We have the half angle identities, but we'll get to that in the next lesson. So what we have here is cosine of sum A minus cosine of sum B. This equals -2 times the sine of this A plus B over 2 times the sine of this A minus B over 2. Okay, so let's go back and let's just write this down here. So basically the cosine of A, okay, minus the cosine of B is equal to -2 times the sine of, you have this A plus B over 2, okay, times the sine of, you have this A minus B over 2, okay? So I'm just going to plug in. A is going to be 13 theta, and B is going to be 5 theta, okay? So let's think about this. I'm going to put equals, and I'm going to carry this over here, and let's just go ahead and say that we have -2 times the sine of, what's A plus B? Well, it's 13 theta plus 5 theta, so that's going to be 18 theta over 2, okay? So I can go ahead and reduce that and say that's basically 9 times theta, right? So sine of 9 times theta. And then basically you could say times the sine of, so the sine of, we have A minus B now, so 13 theta minus 5 theta is going to be 8 theta, okay, over 2. Again, 8 divided by 2 is just 4, so you can put that like that. That's basically all we can do if we're asked to write this as a product. So we have -2 times the sine of 9 theta times the sine of 4 theta. In this lesson, we want to talk about the half angle identities. All right, so we're going to wrap up our section now on the trigonometric identities and get ourselves prepared for solving trigonometric equations. But before we do that, we need to talk about these half angle identities. So let me quickly go back to our handout. So we have all of our trigonometric identities listed here. So these are the ones we've already talked about. Let me just keep scrolling down here. We're going to come down to all the way down where we have these half angle identities, okay? So you see you have ones for cosine, sine, you have 3 for tangent. Again, something you need to basically memorize if you want to go quickly through these problems, but in a lot of cases they're going to let you have these handouts, so it's something you could just refer to back and forth, okay? So I'm going to come back to these when I need them. The first one I'm going to need is this guy, so you can pause the video and write it down, or you can have your handout, whatever you want to do. But the cosine of some angle A over 2 is equal to plus or minus the square root of 1 plus the cosine of A over 2. Now this plus or minus here is there to tell you that you want to take the appropriate sign based on the quadrant that you're in. Remember, cosine is going to be positive in quadrants 1 and 4, okay? So let's go ahead and minimize this. Let's go to the first problem here, where we're told to find the cosine of 67.5 degrees. Now, before I start, let me just put this off to the side. Let me put my identity here. So the cosine of, let's say, A over 2 is equal to, we have plus or minus, you have the square root of, you're going to do 1 plus the cosine of this A over, you're going to have 2. Okay, so let me just slide this down just a little bit. So this is what we're going to be using here. So basically, if I want to write this angle here as some angle over 2, I would first multiply it by 2 to figure that out, right? So 67.5 times 2 is going to give me 135, right? So I would say this is equal to the cosine of 135 degrees over 2, okay? So now this guy right here matches my format right here, okay? So I can use my little identity here. So let's just put equals here. And I'm going to put, since we're trying to find the cosine of 67.5 degrees, remember it has nothing to do with this guy that's being divided by 2. This is what we want here, okay? So this angle right here is going to be in quadrant 1. So we know cosine is positive in quadrant 1. So we want to use the principal square root. So I'm going to say this is equal to the principal square root of 1 plus the cosine of, here's where it gets tricky. This is A, this is A. Okay, so you want the cosine of 135 degrees and then over 2. Okay, so this is what we're going to be figuring out. Now, hopefully at this point you've memorized the unit circle, but if you haven't, I have it here. So basically, if you go to 135 degrees and you look at your x coordinate here, this is going to be the cosine of 135 degrees. So you have negative of the square root of 2 over 2. And all we need to do is replace that here. Okay, and once you have that, it's basically just a lot of simplifying. Okay, so let's just put the square root of 1 plus, again, this is the negative of the square root of 2 over 2, and then all over 2. And I should probably make this a little bit bigger so it encompasses the whole thing. Let's continue this over here. So the quickest way to do this, in my opinion, you could get a common denominator there, but I'm just going to multiply by 2 over 2. Okay, so 2 times 1 over here would be 2. Let me make my square root symbol. And then 2 times you'd have negative square root of 2 over 2. The 2's would cancel. So you're basically subtracting away the square root of 2. So I'm going to put minus the square root of 2. And this is over. 2 times 2 here is 4. Okay. So we can quickly simplify this by realizing, again, you could write this as the square root of 2 minus the square root of 2 over the square root of 4. And we know the square root of 4 is 2. Okay. So I can come down here. Let's finish this up and just put this is equal to the square root of 2 minus the square root of 2, you can't really do anything else there, over the square root of 4 is 2, okay? So that's going to be your exact value if you're looking for the cosine of 67.5 degrees. All right, let's take a look at a similar problem. Now we're going to have the tangent. So we have the tangent of 7 pi over 12. And for this one, again, if you get radians, if you're really good at working with fractions, you can do it in this way. I always just convert these into degrees because it's just easier for me. Okay, so I'm going to first say we have 7 pi over 12 times, again, to convert this, you want to put pi in the denominator, and you want to put 180 degrees in the numerator. Always remember that 180 degrees equals pi radians, okay? So this is your unit fraction. It's basically equal to 1, and we can use this to cancel. So this cancels with this, and 180 divided by 12 is 15. Okay, so you can just cancel this out and put 15. 15 times 7 is 105. Okay, so this will end up giving me 105 degrees. So let's erase this real quick. And I'm just going to put that this is equal to the tangent of 105 degrees. And then I'm just going to double this number, okay, because I'm going to use this half angle formula. So I'm going to say this is equal to the tangent down here of 105 degrees times 2 is 210. So 210 degrees over 2. Okay, so which formula do we want to use? Let's go back to our worksheet. So you have several here to choose from. You can pick this one right here. I think it's probably the easiest. The tangent of a over 2, there's no square root symbol to work with. It's the sine of a, so the sine of whatever this is up here, over 1 plus the cosine of a. So let's go ahead and write this maybe off to the side. We have that the tangent of a over 2 is equal to, again, this is the sine of a over, you have 1 plus the cosine of a. So what do I want to do here? Again, this is going to be what I'm plugging in for a here and here and here, okay? So basically I would say this is the sine of 210 degrees over, you have 1 plus the cosine of 210 degrees, okay? So we don't need this anymore. I'm just going to erase it for room, okay? And then I'll just put equals here. What is the sine of 210 degrees? Let's go back to our little unit circle. So you have the sine of 210 degrees is negative 1/2, and you have the cosine of 210 degrees is negative square root of 3 over 2. So let's now plug in. So the sine of 210 degrees is negative 1/2, and then this is over. Let me scroll down and get a little bit of room here. So again, this is over 1 plus, what's the cosine of 210 degrees? It's the negative of the square root of 3 over 2. So let me put minus here instead of plus. So the negative of the square root of 3 over 2. Okay, so now all we really have to do is simplify this guy. Pretty easy overall. I'm just going to multiply the top and bottom by 2. So this gives me what? This is going to cancel, right? The 2's would cancel, and I just have negative 1 up here. And then this is over. Down here, 2 times 1 is 2, and then minus 2 times this guy right here, the 2's would cancel, and you would just have the square root of 3. Okay, now you don't want to leave this way because you don't ever want a radical in the denominator, so you need to rationalize the denominator. So let's put equals over here, and I'll put negative 1 over 2 minus the square root of 3. Okay, remember how to rationalize this. When this guy is basically 2 terms, you want to use the conjugate, right? So the terms would be the same. The 2 would be the same and the square root of 3 would be the same, but you're going to choose the alternate sign, okay? And the reason for this is when you go through and do the FOIL down here, you're going to have those middle two terms drop out. So you're just going to have the first guy squared minus the second guy squared. Okay, so let's go ahead and put equals here. In the numerator, we know what this is going to be. It's just going to make everything negative. So it would be, let's say, -2, then minus the square root of 3. Down here, you would have the first guy squared, so 2 squared is 4, and then minus the last guy squared, which would be 3. Well, 4 minus 3 is 1, so basically anything over 1 is just itself, so I can just say the answer here is -2 minus the square root of 3. All right, let's take a look at another common problem for this section. So your book will probably say something like finding function values of s over 2 given information about s, okay? So in this particular case, we are given that the sine of theta is 4/5, and theta is basically in quadrant 2, right? Because it's greater than 90 degrees and less than 180 degrees. So you can basically say that theta is in quadrant 2. Okay, so we have that information. Now, what if I asked you to find, let's say, the sine of theta over 2, and then let's say we want the cosine of theta over 2, and also the tangent of theta over 2. And of course, you can get the other ones with the reciprocal identities. We're just going to do these 3 because basically, once you have those, you can get the other ones easily, okay? So first and foremost, where is theta over 2? So theta over 2 is in what quadrant? So this is very confusing for a lot of people, but basically to determine this, you would just divide everything here by 2, okay? Because that would give you theta over 2. Now, 90 degrees divided by 2 is 45 degrees, okay? So that would be less than theta over 2, which is also less than 180 degrees divided by 2 would be 90 degrees, okay? So this tells me that theta over 2 is greater than 45 degrees and less than 90 degrees, so it's got to be in quadrant 1. So it's in quadrant 1. So keep this in mind when you're working with these guys because you've got to choose the appropriate sign, okay, for your trigonometric functions. Now, if we go back to our identities, you'll see to find cosine of a over 2 or sine of a over 2, you need to have the cosine of a, okay, in each case. So that means we first need to find cosine. So let me go to a fresh sheet. We know that the sine of theta is 4/5, and we know that from the Pythagorean identities, we can say that 4/5, which is basically sine squared theta, plus cosine squared theta is equal to 1, okay? So what I can do here is just go through and find cosine of theta. So basically, we've done this a million times. We know if we square 4, we get 16. If we square 5, we get 25, okay? Plus cosine squared theta is equal to 1. I'm going to subtract this away from each side of the equation. So this is going to be my cosine squared theta is equal to, this will be -16 over 25, and then plus 1, okay? So let's come over here. I know that I need a common denominator now, right? So you can just erase this right now and just put 25 over 25. So 25 minus 16 is 9. So I'm going to say cosine squared theta is equal to 9 over 25. So this is where a lot of students struggle. I'm going to put the cosine of theta is equal to plus or minus the square root of 9 over 25. Now, which sign should I choose? Let's go back up, and let's remember that we're working with theta for right now, not theta over 2, okay? So this is where people get confused. They make a sign mistake. So it's theta. Theta is in quadrant 2, okay? If I'm in quadrant 2, cosine is negative, okay? So that means that in this particular case, I want to choose the negative square root, okay? So I want to say the cosine of theta is equal to the negative of the square root of 9 over 25. So the cosine of theta here is equal to -3 over 5, or you could say -3/5. So let's go back up. So let me write this in here. The cosine of theta is going to be equal to -3/5. Okay, so now we have that piece of information. And I want to find the sine of theta over 2, the cosine of theta over 2, and the tangent of theta over 2. Again, we know that theta over 2 is in quadrant 1, so all of these guys, if there's a square root involved, you want the principal square root, okay? So if I go back to my little sheet, we have the sine of a over 2 is equal to, again, we just want the principal one, the square root of 1 minus the cosine of a over 2. So let me first write this out. So we would have the principal square root of 1 minus the cosine of, in this case, this is your a, right? You got to substitute this. This is theta. This will be theta here. And then this will be over 2, okay? So cosine of theta we know is -3/5, so I'm just going to plug that in. So minus a negative is plus a positive, so I'm going to put plus 3/5. Now, how you go about doing this, let me make this better. So 3/5 like this. How you go about simplifying this is up to you. Of course, you could write 1 as 5/5 and then basically add your fractions. Or you could multiply this here by 10/10. It's whatever you want to do, whatever's quicker. Let's just do it this way. So I'm going to say 10 times 1 is 10, okay? And then 10 divided by 5 is 2. 2 times 3 is 6. So 10 basically plus 6 would be 16. So let's say this is 16 over 10 times 2 is 20, okay? So I'd have the square root of this guy. Let me kind of slide this down a little bit. I'm kind of working with some narrow space here. So let's come down here. And let's put this is equal to, of course, 16 and 20 are both divisible by 4. So divide 16 by 4, you get 4. Divide 20 by 4, you get 5, right? So what is the square root of 4/5? Well, the square root of 4 is 2, and then over the square root of 5. Now, I need to rationalize the denominator, so I'm going to multiply this by the square root of 5 over the square root of 5. And so this gives me 2 times the square root of 5 over 5, okay? So all that, just to get this answer here of 2 times the square root of 5 over 5, okay? Now for the cosine of theta over 2, we have a similar formula. We come back here. Again, we're using the principal square root. It's 1 plus the cosine of, in this case, it's theta. Here it's a, but in our case, it's theta over 2. So let's come back and say this would be what? The square root of, you have the 1 plus, what's the cosine of theta? Well, it's negative 3/5. So in this case, you don't have the minus and negative. It's straight up minus 3/5. And then this is over 2, okay? Let me make this a little bit better and make this longer like this. And let's come down here. So let's say 1 minus 3/5. Let's do this an alternative way. Let's just say this is 5/5, okay? So 5 minus 3 would be 2. So basically you would have the square root of, you would have 2/5. If you're dividing by 2, you can just multiply by half. So what you'd have here is the 2's cancel. And so you'd have the square root of 1/5. So let's erase all of this and put the square root, and I made that terribly. So the square root of 1/5. And of course, the square root of 1 is 1, so 1 over the square root of 5. You need to rationalize the denominator, so this is times the square root of 5 over the square root of 5. And so this becomes the square root of 5 over 5, okay? Let's erase all this, and let's slide this all the way down, okay? So this is going to be right there. So square root of 5 over 5, and that's probably too tight. So square root of 5 over 5. Okay, so for the tangent of theta over 2, again, you can come back here and use one of these guys. But again, remember, you can just use your definition of the tangent, okay? So I can just divide this guy by this guy. So I can basically say 2 times the square root of 5 over 5. If I'm dividing with fractions, I just multiply by the reciprocal. So I'm going to flip this, and I'm basically going to have 5 over the square root of 5. And so we see that this would cancel, okay? This would cancel, and I just get 2, okay? So the tangent here is going to be 2. So now we've found all of the guys that we were looking for. So if we're looking for the sine of theta over 2, it's 2 times square root of 5 over 5. The cosine of theta over 2 is square root of 5 over 5. And the tangent of theta over 2 is just going to be 2, okay? So again, if you wanted to find the other ones, you could flip this guy right here in order to find your cosecant of theta over 2. Flip this guy right here in order to find your secant of theta over 2. And flip this guy right here to find your cotangent of theta over 2. All right, let's look at one more problem here, and this just involves verifying an identity. It's just important to get a lot of practice with this, not only for calculus, but because in this section in trigonometry, it just keeps coming up over and over and over again, and there's no general set of rules to follow for this. It's all just practice, right? So manipulating things, trying to make sure it works out, and then just keep going. As long as you're making proper algebraic substitutions, you will eventually get where you want to go, okay? So if I look at this, I have 1 plus the sine of beta is equal to this quantity, sine of beta over 2 plus cosine of beta over 2 squared, okay? So obviously the left side here is much simpler, so I'm just going to work on the right side. Normally you put your equal sign in line here, but I'm going to have to move this all the way over here just because I'm going to run out of room, okay? The first thing I'm going to do, you remember if you have something like x plus y quantity squared, this is the first guy squared plus 2 times the first guy times the second guy plus the last guy squared, okay? So I'm just going to do that here just to expand this guy out. So I'm just going to say that we have basically the sine squared of this beta over 2 plus 2 times this guy. So this sine of beta over 2, and then times cosine of beta over 2, and then plus the last guy squared. So cosine squared of this beta over 2. Okay, so from here, you want to think about, if I look at this guy, what do I have here that I can maybe do something with? So nothing really with the half angle identities. You actually have to go all the way back up to the Pythagorean identities. Remember, we used this earlier. The sine squared theta plus the cosine squared theta equals 1. Okay, so if we think about this, we have sine squared of beta over 2, so this is just some angle, plus cosine squared of that same angle, beta over 2. So this plus this would be 1. Okay, so I can just basically say that that's 1 plus your 2 times sine of beta over 2 times the cosine of beta over 2. Let me get rid of this marking here because I'm kind of in the way. And from here, you're really thinking about now your double angle identities from the last section, okay? Remember what you're trying to get to. If you look at this, you have 1 plus the sine of beta. So for this guy right here, we have the sine of 2a is equal to 2 times the sine of a times the cosine of a, okay? So this is what I have here, right? I have 2 times the sine of beta over 2 times the cosine of beta over 2. So I'm going to go and write it like this, sine of 2 times beta over 2, okay? So I want to put this as 1 plus, we'll say, the sine of 2 times beta over 2. The 2's are going to cancel, and look at what I have. I have 1 plus the sine of beta, okay? And if I go back up, I'm looking for 1 plus the sine of beta, so bam, we got it. And I know these things are kind of hard. I've obviously already worked the problem, so I know what to do. But when you're working with these, don't get frustrated. Again, you can always try to put things in terms of sine or cosine, perform any factoring, perform any squaring, and just get as much practice with these as you can, because when you get to the test, you have to get them done in a reasonable amount of time.